get to apply the concepts we learned in school.
I had never dealt with controlling a 3D robot. Like in a software, I had only done 2D animations in Greenfoot and stuff like that. So this was a new experience for me.
I still remember the first time my robot moved. I was so delighted, screamed at my house, and everyone was like, "Why are you screaming?" I was just so glad for that. It was a great journey.
It was a great competition for me. It was one of the most innovative competition I ever went to.
There might be difficulties in these concepts, but it seemed to be most adventurous to me.
I found this competition very interesting. I wanted to do something like this only, a challenging one. So I chose this.
It was quite challenging, but it was interesting to learn with others.
Giving such a large platform to each student is a great achievement, sir.
We would want more and more people knowing about this because it's a great opportunity to learn.
This competition helped me realize that we shouldn't leave anything behind. We should consider everything we learned.
In the other competitions, there was like only one fixed task which you had to do. In this one, like the bonus task too, it was like different. You could do your own stuff, and because of in eYSRC, you could do like a lot of stuff. Like you can make your own maths, like your own tables where you can do like make your own courses, make your own tracks in which you can solve your own like problems, like for the bonus task. In the other competitions, there was like only one task which everyone had to do, and the main aim was to do it like the fastest time. Like in that one, everyone would come up with the same idea of how to do it, but in this one, like there was lots of other things to do apart from just doing it the fastest.
With respect to doing the tasks and coding, there was no point here where it was not fun. It was challengingly fun. Right? The challenges were fun, and because there was a sense of achievement when you finished it.
It has been pretty amazing to work on the arenas, and it introduced us to a lot of new things, and thus I think it is a stress buster. However, I think we need to find a more efficient manner to handle it along with our school.
This competitions in the past 1 month has done the amount of work that I would have done 3 years.
But you don't see my video, right?
No.
Okay. Now do you see my video?
Yes. Aditya,
This is
can you...
lockdown video.
Yeah, so once the video... We also got to learn about concepts that we actually learn in class and then use it.
With eYantra Robotics Competition here, I could further enhance my knowledge, and I could also imply what I learned in the class, and I could combine this too, and that was worth learning.
Earlier, I used to like to learn stuff, and I used to definitely be in a pursuit for knowledge, but the way I used to read my school textbook was as a textbook. Now I have started to read the textbook like a manual, like something that is directly pertaining to our life, because when we read our empty book, It is never like we're just reading the empty book. We are reading the empty book and we have to apply our own logic and we have to apply our own brain. It's not spoon feeding, right? So similarly, now we are treating, whenever we are studying for school, we are treating it like we are reading manuals, like something that we are actually going to use, apply, and make sense out of. Instead of it being a passive process, now it's a very active process. It just shows that the kind of outlook change that is, this is bringing about.
After this competition, like I'm able to find like much shorter methods, and I'm able to use the particular theorems correctly in the right place.
I have learned lot of things besides theory part, how to tackle a problem. I have upgraded my thinking skill to solve the problem statements.
It would help a lot me in my future as I want to become a data scientist and a programmer.
What we created here, that was something new, and that was something like very powerful. Like we can create many stuff from what we learned, like in eYantra project.
Because of this, and putting our brains to the test at each and every minute and second of whenever we are programming, it has made it really easy to study in a less amount of time and understand the concepts and not read it just as a textbook, as Trinav rightly stated. And I think it at first, before this, I was not really interested in maths and physics. However, this made me realize that this is a bit more interesting than what I had originally thought of it as, and thus that is how it has helped me.
Good morning, everyone, and welcome to the first ever eYantra Students School Robotics Competition. We've been working a lot with undergraduate students, engineering students, giving them an experiential learning experience to complement their textbook and theory learning with very, very good effects over the last almost 10 years. We've been asked to get into schools many years ago, but we didn't have the bandwidth. But this year, we decided to take the plunge and decided to explore what happens when we use the same teaching techniques with younger minds, starting from the 8th standard this year. So from the 8th up to the 11th standard. And what we've experienced has kind of blown us away. I mean, we've been delighted at the way we have engaged with the young students and the kind of passion that we've ignited. And I think we are here to cause a little bit of a stir. So without much ado, let me just talk to you a little bit about eYantra and what we've been up to. And I'll then hand the floor over to our young team who will detail how they have engaged with the youngsters in this robotics competition and what we feel we have achieved in the process. So my talk is about student innovators for local disruption and turning problems into opportunities. Now, the problem is that the world is faced with huge challenges which require a totally different way of approaching them, right? We have climate change, we have all these issues related to climate change, which is premising all the dialogues on the planet. And the traditional way that we've been training our children, I don't think is evoking the right mindset to solve the kind of problems which are besetting the world today. We need a more collaborative approach. We need a more technology-friendly approach. We need a different spirit in which young people are trained and equipped to face the world outside. It's becoming extremely uncertain. So people are saying that tomorrow there's going to be a gig economy. Old corporations are going to die and single people are going to play the roles of a corporation and no job will ever be secure. So into this kind of world, you need a very different mindset. So that's also what eYantra is all about. So let me go on with the presentation. So our problem in India is we have a rapidly growing economy where there's a huge demand for products and services which require automation, right? But we don't train our children both at school and at college how to build and how to respond to these kind of requirements which are emerging in the economy. And typically we find that anything you invent locally costs almost 1/8 of the cost of them of the same thing imported. And happy to say that 50% of the population is below the age of 25, and almost 1 million engineers graduate every year. But unfortunately, they're equipped with the skills to make the most of these opportunities that emerge. So the challenges that we are faced with is all the low-skill jobs are under threat, permanent jobs are going to disappear, and we have challenges like climate change, which needs a different way of discourse between not only people within the country, but with other countries outside also. So how do we train kids to do that? These are the skills we need: design of solutions, investigation of problems, modern tool usage. Most importantly, how to work as a team. Nothing is achieved individually. Everything is achieved as a team. So how do you work as a team? Communication skills are very important, and so on. So this is the effect that we have. This is a young Shruti Joshi who took part in our competition, came to us as an intern, and her story illustrates what eYantra is all about. So a minute of this.
When I just got into engineering, I had a lot of hopes that being an engineer means I'll be solving problems, or I was an electronics engineer, so I was expecting that there would be something related to robotics or IoT or something. But it was just like we are passing semesters, studying for semesters, we have 2 or 3 labs, but none of that was related to the level of work that is done in the industries. Getting to know about eYantra was a game changer for me because I got to know about so many technologies in my second year itself. Before eYantra, at 4:30 our classes used to get over and I used to rush home. Before 5 p.m. I was at home. But after eYantra, we used to stay at college like till 7:37, and we also asked our HOD to allot us a room where we can work. eYantra is not just a robotics or an ideas competition, but it is a platform where you can learn new things. Also, the instructors are really helpful. Whenever we have a problem, we can just post it on Piazza, and in like 2 to 3 hours, we had the solution.
That's me jumping the video ahead.
Been like an added advantage for me in every field, and also the biggest contributor in my resume because my project section is full of projects that I did in eYantra. I gave 2 interviews in my final year and I cracked both of them. The project that I shared with my interviewer was the project that I did on robot operating system and with drones. So firstly, not many people are familiar with what ROS is. So they take a lot of interest in knowing exactly what I did in my project. So that discussion went for a very long time. While I am explaining it to them, if they are understanding, they themselves know that, okay, I have worked on this project thoroughly. That is why I'm able to explain it to them. So they were not many counter questions on that, but the thing is, they were pretty impressed by the technologies that I've already worked on. More than proving anything to your employer or anyone else, I think at the end of 4 years, we always ask ourselves, what did we do as an engineer in the 4 years of our engineering? So you feel that you're not actually implementing anything, you're just into bookish stuff. I would say that eYantra is that one thing which will give you the exposure, is the biggest contributor to the practical learning and real world problem solving skills that I have built as an engineer. So that is what eYantra has given me in the past 3 years that I've been involved with eYantra. So yeah, it has been a blessing for me.
So that's the story, and we teach through competitions. So I'm sure that the young people here with us, the school children, will also relate to what Shruti has just said. So essentially what eYantra has discovered is a way of teaching through the medium of a competition, right? And we find that extremely motivating, and we can achieve a hell of a lot. Over 6 months, we can teach some pretty cool skills. So this is how the numbers have been growing. And since 2012, it's been almost exponential growth. Even in COVID, we've not been hit too badly in the sense that almost 10,000 students from 1364 colleges took part in our competition. And the kind of skills that we've been teaching the engineering students is illustrated by this theme, where we taught them how to solve a problem where they have to visualize a robotic snake, and then they have to use design thinking, 3D modeling using open source tools, simulation, microcontroller programming, and all that to make and build a snake to solve a problem. And this is what the snake looked like at the end of their 6 months experience. This snake has to go around on the arena identifying rodents which are represented by patches of color, red and blue, and they have to avoid the obstacles like the ramps and stuff like that. So these are the complex skills that we totally on ground. So this is what we wanted to bring to younger students. In fact, it's quite interesting that as a result of the skills that the engineering students have learned in the competition, they've done startups using exactly those same skills, like Drona Automation, which is building sewer cleaning robots in Bangalore, Nibrus Technologies, which is surveying mines using drones, using exactly the technology we taught them, Catamaran, which is doing amazing work with mobile robots and stuff like that. So in this year, also under lockdown, in fact, we've achieved a lot under lockdown, but that's not what this meeting is all about. But almost over 10,000 students have registered and they are competing under lockdown conditions. And we've opened it up a little bit internationally to Bhutan, Nepal, Bangladesh, Laos, and so on, Southeast Asia. And we've been having very good experience, especially with Bhutanese and Bangladeshi students. And we are doing hardcore industry 4.0 themes. So these are the kind of stuff we actually are teaching them online. And because it's lockdown, we've been teaching them through a simulator, the same way that we've taught the youngsters in the school competition. So this is what the Vitaran drone theme looks like, where we teach the students how to program the control system of a drone, right? And to solve a problem of delivering parcels from one place to another. Now, this is a totally physics simulation, and they have to program it using Python and all that. And all the skills learned here can help them program a real drone. And that's just 10% more work, right? Where they have to address the real world issues due to a real drone. But most of the skills are taught in a simulator. Don't underestimate the value of a simulation, because when you teach pilots to fly an aircraft, you don't give them a real plane, you give them a simulation, right? And once they've learned everything there, only then they graduate to an aircraft. So don't underestimate the value of working inside a simulator, right? You can learn everything that you need to if the simulator is a good one. So I'll go on. And we've been also setting up labs, right, through the eYantra lab setup initiative. Our target is 1,000 labs, and we've reached about 400 plus labs across the country in engineering colleges. And one of our innovations is to give an entire lab inside a box. So this is called an eYantra lab in a box project, where we give you this entire lab and we give you all the training online to use all the equipment. All this has arisen out of the desire that I had almost 15 years ago to try to teach embedded systems through the distance education program. It was an utter failure. If I had all these tools available at that time, it would have been a real success. But that's how eYantra was actually born, right? How to teach at a distance. This is what teachers are saying in the labs about their experience.
Impact of the eYSRC lab on the project is quality of project has improved. They started thinking about some new project, new ideas, altogether new things, and now these projects, they want to patent the projects as well. Actually, she cried in my lecture because she was so afraid of the programming. And now you can see she is standing here in the regional competition, and she is so good in coding now that she is learning new languages. She is learning Python, R programming. Not only for the juniors, she is teaching her seniors as well. And they are conducting classes for embedded system, Python, everything. That too after college hours.
So that gives you a little experience of what's happening to engineers. And we find that the same thing is actually happening with the school students that we've been interacting with. The same empowerment, the same excitement, the same discovery of passion, and finding meaning in what their textbook is actually teaching them in, say, math, physics, and stuff like that, which are very, very important things. I won't go into the innovation challenge. We have one competition that trains you in skills, and we have another competition which trains you how to use these skills to solve real problems in society, where the end goal is to build a startup. I won't go into that, but this is just to show you what we have there. And this is the effect that we have from the feedback that we've collected. We put it into a word cloud, and we find that self-confidence, technical skills, problem-solving abilities, things like that are really sort of improved as a result of our engagement with the students. And this is some of the education platforms that we've been building. Most importantly, this year we have this mobile robot with a collaborative arm, which we are teaching students to use through a simulator. So basically, it means that all these platforms, to actually do anything with them is very difficult. So what we are doing is creating a new educational platform where we'll make it much easier to work with robots, where we'll present the robots in a way that many of the minor details are taken care of, and we can train students to actually build a project very fast within, say, a month's time using these kind of robots. Now we are translating these same skills that we've acquired. We are translating the same learnings now through a school's robotic competition as an experiment. And the results that we've had have been extremely heartening. All credit goes to the mentors of eYantra and to the young students who've risen to the challenges very beautifully. We are very proud to say that. And so this competition tries to bring project-based learning to schools through a competition to give hands-on experience, right? So we teach them how to think, ideate, innovate, out-of-the-box kind of solutions to real problems, which we present to them within the context of a simulator at the moment, only because of lockdown. Okay, so it's been a roughly 10 weeks competition targeted at 8th to 12th standard. Actually, we didn't want to distract 12th standards, so we used it up to 11th standard. 10 weeks competition, and registrations were in November, completely online. We gave them all the resources online. We had feedback and discussion fora, and we had assessment through quizzes, tasks, and experiments. And almost 270 students took part in the pilot, as 71 teams from 44 schools. And we also had this year, we had Royal Academy in Bhutan take part, and we were very impressed by what they achieved. So the participants were 231 students eventually from 61 teams, 37 schools, and the finalists that we'll be having here with us over the next 2 days are 16 teams from 14 schools. And this is the kind of experience that they've been sharing with us about their experience of eYantra.
We also got to learn about concepts that we actually learn in class and then use it.
With eYantra Robotics Competition here, I could further enhance my knowledge, and I could also imply what I learned in the class, and I could combine this too, and that was worth learning.
Earlier, I used to like to learn stuff, and I used to definitely be in a pursuit for knowledge, but the way I used to read my school textbook was as a textbook. Now I have started to read the textbook like a manual, like something that is directly pertaining to our life. Because when we read our empty book, it is never like we're just reading the empty book. We are reading the empty book, and we have to apply our own logic, and we have to apply our own brain. It's not spoon feeding, right? So similarly, now we are treating, whenever we are studying for school, we are treating it like we are reading manuals, like something that we are actually going to use, apply, and make sense out of. Instead of it being a passive process, now it's a very active process. It just shows that the kind of outlook change that is, this is bringing about.
After this competition, I'm able to find much shorter methods, and I'm able to use the particular theorems correctly in the right place.
I have learned a lot of things besides theory part, how to tackle a problem. I have upgraded my thinking skill to solve the problem statements.
It would help a lot me in my future, as I want to become a data scientist and a programmer.
What we created here, that was something new, and that was something like very powerful. We can create many stuff from what we learned, like in eYantra project.
Because of this, and putting our brains to the test at each and every minute and second of whenever we are programming, it has made it really easy to study in a less amount of time and understand the concepts, and not read it just as a textbook, as Trinav rightly stated. And I think it, at first, before this, I was not really interested in maths and physics. However, this made me realize that this is a bit more interesting than what I had originally thought of it as, and thus that is how it has helped me.
So, in summary, we need to prepare our young people for a future in which jobs are in short supply. So, we need more job creators. We need entrepreneurial thinking in our youngsters. The future challenges are going to be premised by grand challenges like climate change, which are going to affect our lives in dramatic ways that we cannot anticipate right now, which needs a very different mindset in our students, a problem solving mindset, a cross border collaboration mindset where we can work with kids from other countries. And eYantra wants to make that possible by exposing them to children from other countries. In fact, what the Bhutanese students said to us was so delightful, in the sense that they said that we'd like to work with Indian students to solve problems, because they were very impressed by the sorts of minds that they saw in the interactions from the neighboring country. And we like to see problems as opportunities. And as Amitabh Bachchan said in their film Padman, he says, don't see us as 1.3 billion mouths to feed, see ourselves as 1.3 billion minds which can engage in avishkar, in invention. And that is the hope of eYantra. And we feel that this competition is one step that we've taken towards creating a very different outlook amongst our young people at school, right? Of experiential learning, in actually thinking of themselves as empowered individuals which can make a change in society. So our learnings have been that school is a very critical crucible. We are very delighted that we've approached the schools with the same learnings and technology that we've been working with engineering students. We need to use it to kindle the latent talents and to encourage self-discovery, because that's the most important thing. We need to change pedagogy in the sense that we need to use technology to connect and to contextualize knowledge and kindle a passion. The passion is the most important thing. And more importantly, a need for collaborative problem solving and teamwork. This is something that we used to learn in the sports field in the old days, but nowadays kids are becoming more and more couch potatoes and taking part less in sports because of technology and mobile phones and things like that. Let us utilize that to help them do something collaborative online with which they can learn a lot. Most important thing is how to discover a passion early on. Little is achieved in life without a deep interest and passion. And here we are only limited by our imagination. And this is what is the biggest learning. What the kids have responded to very strongly is the passion and the interest and the sense of collaboration that our mentors, our team members have been expressing in their engagement with the youngsters. And that kind of very democratic learning environment that we created with bright people all around has really made magic happen. And now next, to share the way magic was made to happen, I'd like to hand the floor over to two of my young colleagues at eYantra, both very passionate and both very enthusiastic. We have Aditya Agarwal and we have Arjun Sadanand, who along with Deepa, who's here also with us, have actually managed the entire school initiative in themselves. So over to Arjun. So this is the team. Incidentally, average age 25, and this is what we can do if we just empower youngsters and tell them you can do it and just solve the problems as we go along, right? And we have representation from all across the country, and there are a number of initiatives that we have in the project. Let me just, yeah. So it's not only the competition, lab setup, innovation challenge, we have MOOCs and all sorts of things, and including now the school robotic competition, which I believe is here to stay. So without much ado, I shall stop here and I shall hand the floor over to Arjun Sadananda to take over from me. Arjun, I think I've kept within time. Maybe I've saved about 5 minutes, and we can keep to time in your talk now.
Yes, sir. Thank you so much. And is my audio clear? Just to verify.
Yes, Arjun. Yeah, it's clear.
Okay, so I think I'll ask Deepa to start with the presentation for just summarizing the entire of eYSRC in a very quick presentation. So Deepa, could you start the presentation?
Yeah, sure. I'll share the screen. Can you see the screen?
Yes, we can.
Okay. Thank you so much, Kapil and Arjun. So, welcome all of you for the grand finale of School Robotics Competition. And we have had a really interesting journey. So, to start with, yeah. So to start with, we have had a theme called Intrepid Explorer. So in this theme, what we did is we depicted the behavior of an explorer instinct, of a young mind, young adventurous mind. So here, what we exactly did is we have depicted this adventurous mind in a form of learning, the curiosity to learn. So here we had explored the domain of robotics and different concepts of STEM. So we'll just show the glimpses of what all we did in this whole journey in a form of pictures and in a form of video. So let's watch the theme film of this Intrepid Explorer, what all finalists have done throughout the journey, and the final task is being presented in a form of a video. Just watch. Could you confirm?
We're not getting the audio. Maybe you have to optimize for video and audio when you share the screen.
Second, I'll just check that.
It happens when you initially share.
Okay, then I'll stop and share again.
Yeah, do that.
Yeah. Now, confirm. Audio is coming.
No, we're not getting audio.
One second. I'm so sorry about that. Yeah, could you please play that? But then, one second. I'll just try it again and then let's see. So when we share, okay. Okay, Aditya, could you please play that? Because I can't see the media audio that should go.
I think I'll try once. If mine doesn't work, then so that yeah.
Thank you, Arjun. So, good. Yeah. So we all have watched the final task that has been assigned to all the participants. So that was a team film. So we started our journey with registration. So we started on November 17th when we started the registration, and it went till 50, like for 15 days, and then till the final task. Like December 1st, we started the first task, task 0, and then the final task was till February 14th, and now we have the grand finale. So it was like the journey was all about having the software installation, and then task 0, which was keyboard interfacing and so on. So we'll go ahead. Wait. So mainly this competition covered the resources in a form of empty book, videos, and the assistance was mainly given through the WebEx live interactive sessions. We had a doubt clearing session also on Google Meet. So one-to-one doubt clearing sessions we had. So we used to get a call that, okay, I'm not getting this. So that time we used to have a one-to-one session. And then the main journey was the essence of the main journey was the discussion forum where we used to interact, where we post and all kind of things. So discussion forum was mainly on Piazza forum. So this was the kind of assistance that we had provided, and the assessment was based on the polls that we used to take in live interaction session, and the quizzes at the time of the sessions only. And then the main thing was the problem statements and extra activities that we used to give for each task. So we'll check that in detail. So here in this presentation, we'll check the glimpses of what we had done with the school students. So this was MD book. This is an MD book snapshot. So here, if you could see, there's a learn section and there's a task section. In learn section, we provided all the details like the concepts and VBOTs related, reprogramming related concepts were covered in the learn. And task mainly had the problem statement, the submission guidelines, so all those things. This was the first time we tried this MD book, and it was very good. Like it was very interactive, and students also felt the easiness of using this. So this was MD book, and next we have the live interactive. Arjun, next. Yeah. So live sessions we used to take on WebEx, and here you could see like how we had taken the similar to this WebEx session. We used to have it in for all students, and we used to ask queries, doubts, and all those things. So the next thing was one-to-one session. Arjun. Yeah. So for example, if the students are not able to understand any concepts and they are having doubts in tackling certain tasks, that time we used to have a Google Meet where we used to call everybody on one page, and we used to simply ask the queries, and we used to resolve those queries. So if you could see the snapshot, so we have the snapshot stating like, okay, there's a problem with the keyboard interfacing and how we resolved it. So all those things. Next, yeah. So here is a snapshot of a discussion forum, that's Piazza. So here we used to interact with the students always. So every time any student had any query, anything, we used to put it here. Even the updates of releasing of tasks and deadlines, we used to post it here. So that's all about the Piazza forum. Yeah, the first day, before starting with the task 0, we had an inauguration function where we had everybody who joined the session. Like, there were all 70 teams initially who joined for the competition, as Kavisa mentioned. So all teams joined, and then we started the journey. And then slowly, we have around 16 top performing teams who will be performing now. So kudos to the 16 teams who have performed well overall in the complete journey. So yes, Arjun, can you go next? Yeah, so this was a discussion huddle that we had in between where we actually discussed with participants their thoughts, their feelings, what the Eureka moment we had. So these are some snapshots of our discussion huddle. Yeah, Arjun, next. Yeah. So this is Arjun. Would you like to?
Yeah, thank you, Deepan. So let me share my video as well so you guys can see me. Okay, so good morning everyone on WebEx and on YouTube watching, and I'll be talking about their experience, their adventure, basically the 10 weeks adventure. So all the 16 today in the entire two session that we'll be having, we'll be sharing 16 different teams that have been through a pretty amazing adventure in the last 10 weeks. So I'll try to summarize those 10 weeks in 10 slides that come ahead. And the final task, as you know, final objective at the end of all these 10 weeks adventure was to basically successfully go through this obstacle course that you see, with the first section being the wall following area and the second being the line following. And if you think of any robot, there are three parts to any robot, right? There's a sense, think, act paradigm. So we kind of divided even our tasks in such a way that we thought of sense, think, and act separately, and then we integrated together to finally complete the task. And clearly, the line following section is actually having an upgraded level of sensing because we use image processing and line following for sensing, right? So there's a lot of things happening in just these two sections, and the question is how do we get there, right? How do we reach those final goals? And to do that, we had a series of tasks, 0 to 3 for the wall following section, and then there was a bonus task in between, which is a very exciting task. We have a slide for that. And then there's two tasks and the grand final task, right? So yeah, I'll just probably show you a video to kind of summarize all of it in one quick video, and then we'll talk about it a bit more. Um, Yeah, so that was the journey of 10 weeks summarized in a 4 or 5 minutes video. The first time I saw it, I was almost emotional, and I can see on WebEx all of them just cheering and applauding virtually. So I guess all the students are also very excited. Um, so yeah, now I'll just move to the next slide if I.
Arjun, not only the students, but we are all very excited.
Yeah, I think my full screen was not letting me switch slides. Just a second. Okay. Right. So that went by pretty quickly. So I probably just highlighted a little more in one slide for each task, so we can talk about it a bit, and then we'll move on to the highlight of the day, which is the actual tasks that the teams have come up with. So yeah, this was the first task, task 0, VBots. On the left, you see the interface that VBots has, and on the right, you can see all the different softwares and things that we have been using. So that's the VBots logo, the Python programming that we have been doing, and the robot that we have been using, ePuck, is on the bottom left, the point where my cursor is at. So all this looks very new when you first look at it, right? So the first week was dedicated just to get familiar with the interface. So the objective was just to make a keyboard controlling program and just move the robot around in a square shape, right? So that was the first week, pretty straightforward. Things get very exciting. It's a huge step to task 1, where we kind of start right into the actuators of how differential drive robots work, and the entire kinematics of it. We implement the physics, the maths of differential drive robots, and then try to control it using basically what is an open loop controller, and try to implement the shape tracing that you see on the arena. So we give the specific dimensions of the arena, and just by knowing every details of the arena, you can try to actuate it just by open loop control, where you don't have feedback from the environment. You just use the actuator information to pure maths and physics to implement the shape, right? That was task 1. And task 2 is where the robot gets a little smarter. It starts sensing the environment. So as you can see in the GIF on the bottom left, the robot senses that there's an obstacle and then it avoids it. So that was the second week, where you use the sensors to go through this like a scattered obstacle. Those are scattered randomly. So it starts very organized, and when you start the run, it scatters everywhere. And the ePuck's goal is to reach the finish line through this scattered arena, right? So that was sensors week. And then we had task 3, which is one of my favorite weeks. I'm not sure how many would agree on this being their favorite, but this was the controllers week, where we really made the robot. Okay, I see some of the students agreeing. So this was where we had, as we pointed out in task 1, this was the open loop controller that we had, and in task 3, we got a lot more smarter. We started using the sensors, sensing the output, sensing the behavior of the robot, and making the necessary corrections using a much smarter controller, and sending that to the robot in order to behave a lot more smartly, right? So the thinking part just upgraded by a huge margin. So sense, think, and act, we have just gone through the 3 parts of the robot's sense, think, and act paradigm. So this is the arena on the right that you see that the robot had to go through. A 3-dimensional arena. There's a second floor and a first floor. So the robot had to go through that. And on the top, you see a bang bang control. And what we actually implemented was a P controller and things like that. So, and here you see the differential drive model and the unicycle model, and trying to model the robot itself in different ways in order to make control easy. So unicycle model made it easier to control and things like that. Then we took a break since we had finished the first major division of the arena. We took a break to just look back at all the things that we have learned till task 3 and kind of integrate it all together and also get in your own creativity, the team's creativity. And here is just a small sample set of all the things that the teams came up with. Here are 6-7 teams, creative designs of the arena. They themselves created the arena, the problem statement, and the solution to the problem statement. So there's, as you can see on the particular slide, there's a pretty intense level of creativity going on right here. And the objective was also to implement all the 3 different things that we have been learning. The task 1, 2, and 3, use all of that knowledge to demonstrate it in this particular arena. So it's not just the art, but also the technical skills that they have learned have been implemented in this, in each of these arenas. So that was a bonus task, a very exciting task that was very abruptly introduced. It was not part of the original plan, but we are so glad that we did that. So it was pretty cool to see all the students' creativity come out in this way. Then we went to phase 2 of the competition, which was task 4, where the image processing starts in, and the OpenCV comes into the picture. Here's the OpenCV logo on the bottom right. So there we do all kinds of things. We do thresholding, we do contour detection, we do shape detection, and then as you can see in this particular example here, the task was to find out there's echo. Yeah, the task was to find out the shape and color of the object. And on the right, you see the arena. So there was an obstacle just appearing at random, like the random shape appears in front of it, and it has to detect the shape and color and make the next decision. So here we kind of introduce decision making. So that is one thing that we did not really emphasize earlier. Controller, sense, think, act was there, but thinking just got another level. There was level 1, which was controller. There was a upper level above it, which takes decisions. And this was task 4, to make decisions basically. So decision making was introduced here, and image processing obviously was the highlight here. Finally, in task 5, which was, we are nearing the end now. Excuse me. So in task 5 was the accumulation of all of the earlier tasks together. It includes the controller design, it includes the image processing, it includes all of the differential drive, unicycle, P controller. Over here you can see different effects of different KP values. Here you can see how to think of even writing a program. By this point, the program is getting more and more complex. So you can't straight away get coding, right? So you'll have to think of flow charts, how to really plan out your algorithm before you get into the writing of code, right? So here we talked about that, how to design flow charts and how to convert that flow chart into Python code. That was what we discussed in this session when the necessity came up. Earlier, we used to just write code straight away, right? Here, things got more and more complex, and it's very essential to start thinking of the entire process first and then getting into the coding. So that was one. And finally, we have reached the grand finale, the full theme implementation. So here, there was a lot of things that happened. Here, actually, when we talk about the evaluation, probably we'll get to know a little more behind the scenes in this particular arena. But basically, this is just an integration, as you can see, of task 3 and task 5, but with a new element of the transition. So a lot of new challenges as well. The 90-degree turn is a new challenge. I'm sure a lot of the 16 teams here are enjoying the fact that they just managed to complete it somehow. There was a difficulty level to it, which was introduced all of a sudden in the end. And we are very happy to see all the 16 teams making it through the entire arena. So the evaluation, I guess I'll just come to the serious part a little bit. The evaluation of what we value when it comes to the submission, right? So progress obviously just defines the functionality of your code. And that obviously comes right at the top. If the code is not functional, it's not of any value. And therefore, progress represents the functionality. Time score represents the performance, right? How good your robot is. If you have a more efficient program, it will run faster. So time score is represented there by 50 marks. And finally, one of the usually underrated, but supposed to be much more seriously taken, a code score. where we go through the code and give it a score on different parameters. What are those parameters? These are the 4 parameters that we evaluated. Robustness of the code. We had some hidden test cases that we'll be testing uh, their code in that they have not seen, and if the robot runs in those test cases, that is a robust code, right? And modularity. How modular is their code? Are they able to reuse the code in different settings? If they had to rewrite the code for something else, is it modular enough to reuse the code, right? Documentation and clarity. It's not always as it has been mentioned earlier, teamwork is a very essential part of any project, right? And whenever there's teamwork, there are multiple programmers working on same projects. And when that happens, documentation clarity becomes of utmost importance, right? And therefore, documentation and clarity has the necessary weightage. And finally, the approach. This is the things that we have been discussing in task 3 and 5 and all of those tasks before that. And what particular approach did they choose to use? That has been evaluated as the final criteria. And that kind of summarizes the entire final task and their journey of how they reached the final task. And I think now it is almost time to start the actual event for the day. With that, I'll hand it over to Deepa ma'am.
Thank you so much, Arjun. Yeah. Thank you so much for sharing the glimpses of the complete journey. We hope everybody got to see what exactly we experienced and we did with the school students. And yeah, so we'll start with our first panel. We have Professor Supratik Chakraborty with us, and we have Professor Ajit Rajwade with us. So, Kavi sir, would you like to share anything?
Yeah, Professor Rajwade and Professor Chakravarti, welcome to the eYantra Schools Robotics Competition. It's our pleasure to share with you what the young people have actually achieved with a little bit of help from us, but all their own work. And it's shown us, it's blown us away in what young people are really capable of achieving. It'll be nice if you unmute your video so our friends can see what IIT professors we have here with us. So Professor Rajwade, incidentally, is our the expert on image processing and topics like that. If you want state-of-the-art Gyan in image processing, you come to Professor Rajwade. And Professor Supratik Chakravarti is very much in the area of formal methods. How to write or build systems which are safe, secure, reliable, and there's a lot of mathematics and formalism that goes into building these kind of systems. So the science of that and the technology of that is what Professor Supratik is concerned about. How to build safe and reliable systems. There's a lot of mathematical and formal work in that. So it gives me great pleasure to have them with us. Perhaps a few words from each of them before we start, and then we'll hit them with the 4 teams and the work that they've done. Supratik, would you like to go first, and then Ajit?
Yeah, sure. Yeah, it's a privilege to be part of this evaluation. Thank you, Kavi, for inviting us. And I just wanted to mention, I don't know if most of you have been tracking that early yesterday morning, the Perseverance rover landed on Mars. NASA made an amazing, it's a triumph of science and engineering, I think. If you have not yet seen it, you should go and see the recordings on NASA TV. And this rover, which is now on the surface of Mars, joins the previous Curiosity rover, which is already on the surface of Mars, is going to use a lot of robotic stuff that all of you are, I guess, using and learning and doing your projects with. And this is actually going to advance science, pushing it beyond the frontiers that we know today. So, hopefully some of you who are in the final today will one day, participate in such projects which actually put human creations on other planets and then really advance science. So, I would request all of you to actually take a look at some of the videos NASA has put out about how the rover was landed on Mars. An amazing feat of robotics, engineering, science, technology, everything, and how the Perseverance rover actually sort of negotiates its way on the surface of Mars. It's an amazing piece of robotics. So hopefully that will inspire more and more of you take up robotics, and what Professor Kavi is doing is absolutely amazing. I mean, giving all of you the opportunity to sort of participate in nationwide competitions. Thank you, Kavi.
Thank you, Supratik. It would be nice to see you, although
My video is turned on.
I don't see it.
Oh, is that so? I mean, I can.
There's a bandwidth problem, like there's a
There's
yellow
a little
triangle.
triangle, yellow triangle on the thing.
Oh, really? Over here, it shows my picture as one of the
Okay.
insects.
Now I can see you, Supratik.
Okay.
Okay. I don't yet, but that's okay. We hear you. Perhaps we
Okay.
should move on to Ajit. Ajit, there's a lot of image processing in what we are doing, so I thought you'll add a lot of value to understanding and appreciating what the kids have achieved. And just imagine if in the eighth standard they have learned these skills, by the time they come to you, they'll be sort of testing you quite a bit.
So it's if such kids come to us for masters or PhD, they're going to give us a tough time. Then we have to think of sufficient challenges for them. It's not going to be
Yeah.
easy for us, right? So Kavi, you're making life difficult for us, I think. For the
But we enjoy
future.
that, don't we?
So yeah, of course, it's a difficulty to be enjoyed. Some difficulties are very good things to happen. So I of course, so I'm very happy to be part of this competition for judging. And I completely agree that I'm going to be in for some very exciting demonstrations. I've been part of a similar event a few years ago, not with eYantra, but in another organization, and the kids were amazing. And I'm expecting similar things from children here. Okay, that we're going to get to see some really nice demos, and it is absolutely amazing. I'm just going through the specs of the competition that Kavi shared with me. And if children in the 8th standard, 9th standard are being able to do such things, it is really, really creditable. It's also creditable of eYantra to be facilitating such a thing at such a large scale and encouraging children in such a beautiful manner that takes us outside usual textbook learning into something that is so hands-on. I believe that it teaches you technical skills, practical skills. Like the other person Arjun was mentioning, it teaches you a lot of teamwork, how to work with each other and help each other out. Okay? So there are many, many things to be learned in an endeavor like this. And lastly, I will say it is also a learning experience for us as judges to see, such good things, such good demos, and it's going to be most likely, I'm telling you, it's going to be very tough for us to decide who is the top person. Okay. So apart from that, I think Supratik has given a beautiful example of the Mars rover and what you're doing as children today. May it lead to something, to you participating in projects of similar magnitude as the Mars rover. So with this, I'll give everybody best wishes and I'll pass on to Kavi.
Yeah, Ajit, I was just thinking to myself, we have older children, which is our team, teaching younger children. And then there are yet more older children, which is us sitting in IIT, teaching the younger children. And I think the important thing is what we associate childhood with a curiosity and a passion and excitement about life. And
Yes.
I'm happy to see that this same spirit is unchanged, and it's a stock in trade for what we do, because without passion and a deep curiosity and interest, you would not have IIT faculty, or for that matter, faculty anywhere. And I think it's this spirit which is the most important thing, which I see not only in the eYantra team, but in the youngsters. And this is something that we need to capture and keep it alive, So with that, I'd like to hand the floor over to Deepa now to kind of hit us with the remaining program.
Okay, thank you so much, sir. Thank you. What we'll do is we'll have a 2 minutes breakout session with our judges, and meanwhile, Rishikesh, you are there?
Yes, I'm
Yeah.
audible, right?
Yeah, you are audible. So maybe what you can do is you can keep the playlist ready. So we have 4 teams in each panel. So panel one, there are 4 teams who have booked their slot on their own. They were ready to, go first, second, third, and fourth. So maybe we can keep the playlist ready and we'll just have a breakout session for 2 minutes with the judges and come back.
Yes.
Yeah.
Okay, so how do we join the breakouts?
I hear an echo somewhere.
Yeah. Jason needs to mute himself.
The final task consisted of a cumulative, deployment of what they had learned throughout the competition. So, and it involved like the first section was wall following and the second section was line following. I'll not spoil it much for you because, okay, you can see me now. So I'm sitting in the lab over here. So I'll not spoil it much. As you can see, the videos in store are pretty entertaining as well as like insightful. So yes, let's just wait for those and stay tuned. So,
one thing I got to know time management, mainly in academics and this robotics.
I got to learn that hey, I need to be a better person. I can at least try to help my teammate in a way, cooperate better. So yeah, this is what I've learned.
Teamwork and collaboration skills were very good at it, as we all have worked together to complete our task.
I learned that if we are not knowing anything, that we should not give up. We should have a try on it.
Most important thing that I learned from this was this various skills, which includes coding, patience, critical thinking, analytical thinking, and when it comes to MD book, it even includes my comprehension skills. So it has really helped me develop those skills, and it even enhanced the way I do things in a more effective manner.
This made me think unique than others. I never thought that programming is something like too much mathematics things will work. So I got to know many things which helped me in mathematics also.
One more thing I learned was organization. It really brought a change on me that everything has to be done stepwise and has to follow a pattern.
There was no eYantra. If someone asked me to code a certain program, I'd just like run away saying like someone else can take it, because I really didn't know much about it. But now like I actually step forward asking if what I'm saying is right, or if we could use this instead of that. Something new is shown to you, you'd rather run away than actually face it. But then once you start learning about it, you'd say, I'm gonna do this, no, I'm gonna do it, you're not gonna touch, you're not gonna help me at all. So yeah, your confidence is like built over there.
पहले तो जब हमने स्टार्ट किया तो हमें ऐसा लगा नहीं था कि हम कर पाएंगे, लेकिन अब ऐसा नहीं लगता। हमें लगता है कि हम कर सकते हैं।
We get to apply the concepts we learned in school.
I had never dealt with controlling a 3D robot. Like in a software, I had only done 2D animations in Greenfoot and stuff like that. So this was a new experience for me.
I still remember the first time my robot moved. I was so delighted, I screamed at my house, and everyone was like, "Why are you screaming?" I was just so glad for that. It was a great journey.
It was a great competition for me. It was one of the most innovative competition I ever went to.
There might be difficulties in these concepts, but it seemed to be most adventurous to me.
I found this competition very interesting. Like I wanted to do something like this only, a challenging one. So I chose this.
It was quite challenging, but it was interesting to learn with others.
Giving such a large platform to each student is a great achievement, sir.
We would want more and more people knowing about this because it's a great opportunity to learn.
This competition helped me realize that we shouldn't leave anything behind. We should consider everything we learned.
Just programmers of encyclopedia. So all of the teams, they have a team ID as well as a team name basically. So we'll be mainly referring to them by their team name. So we have 4 teams lined up for this panel. The first is Scambot, programmers of encyclopedia, team HVB, which is team ID 66, and team ID 109, which is called Systech Minions. So I hope all of you are present in this live stream, and all of you are like ready with your videos and so on. So as soon as the judges return, we'll first start with Scambots, then POE, I'll say, the programmers of encyclopedia, then team HVD, and then Systech Minions. In that order. So you could just
We also got to learn about concepts that we actually learn in class and then use it
with eYantra robotics competition here, I could further enhance my knowledge, and I could also imply what I learned in the class, and I could combine this too, and that was worth learning.
Earlier, I used to like to learn stuff, and I used to definitely be in a pursuit for knowledge. But the way I used to read my school textbook was as a textbook. Now I have started to read the textbook like a manual, like something that is directly pertaining to our life. Because when we read our MD book, it is never like we're just reading the MD book. We are reading the MD book, and we have to apply our own logic, and we have to apply our own brain. It's not spoon feeding, right? So similarly, now we are treating, whenever we are studying for school, we are treating it like we are reading manuals, like something that we are actually going to use, apply, and make sense out of. Instead of it being a passive process, now it's a very active process. It just shows that the kind of outlook change that is this is bringing about.
After this competition, like I'm able to find like much shorter methods, and I'm able to use the particular theorems correctly in the right place.
I have learned a lot of things besides theory part, how to tackle a problem. I have upgraded my thinking skill to solve the problem statements.
It would help a lot me in my future as I want to become a data scientist and a programmer.
What we created here, that was something new, and that was something like very powerful. Like we can create many stuff from what we learned, like in eYantra project.
Because of this, and putting our brains to the test at each and every minute and second of whenever we are programming, it has made it really easy to study in a less amount of time and understand the concepts and not read it just as a textbook, as Trinav rightly stated. And I think at first, before this, I was not really interested in maths and physics. However, this made me realize that this is a bit more interesting than what I had originally thought of it as, and thus that is how it has helped me.
Arjun
Yes,
Aditya.
sir. And for the benefit of the audience on YouTube, the submissions also include a little bit of entertainment at the end of it. So it will start with the demonstration, and then they also tell their story and maybe a few bloopers at the end of the video. So we'll start with the first team for the day, Rishi.
So the first team for the day is Team Scambots from Gayatri Shiksha Niketan in Jamshedpur, which is in central India. So the team consists of Krish, Kaustav, Rahul, and Anish, basically. So here is their short video.
Hello, this is Krish from Team Scambots. Our team ID is 1 and we are from Gayatri Shiksha Niketan class 11.
Hello, I am Costa Malik from class 11.
This is Anish Kumar from class 11.
Hello, I am Rahul Gupta and I'm studying in class 11.
Our approach to move the ePUC robot throughout the wall following course is that we have used two proximity sensors instead of the one that was available to us in the ePUC. So we have used the proximity sensor number 6 and the proximity sensor number 1, and using that we have implemented the P controller in such a way that the sensor values of the sixth proximity sensor has the inputs to the right motor, and the proximity sensor values of the sensor 1 has the inputs to the left wheel. And in this way we are calculating the error, then we are calculating the extra angular velocity required for the epoch to turn accordingly, and this is how we are making the robot follow the wall. The only challenge that our team faced was that when the robot was following the wall, it was jumping out of the arena. So, to account for that, we needed the epoch to have knowledge about both the walls, and accordingly, we calculated two different error values for the proportional controller to act on and thus follow the wall. Our approach to make the epoch robot follow the line following course is that first we set a constant center value, and then we see and calculate the centroid of the current image using the camera and the concept of image moments, and then we calculate the error value by subtracting the center from the centroid, and then we put that error into the proportional controller, and then we find the extra angular velocity that we need to subtract and add to the left and the right motors respectively. And now something special.
ये हम हैं, ये हमारा कोड है और ये है हमारा ओलंपिक.
Music.
गजब बेइज्जती है.
So yes, that was Team Scambots from Jamshedpur. And yes, could you all unmute yourselves and your video?
Yeah, we have.
So I take it the last bit of the video was not part of the theme run.
Yeah, it wasn't. But yeah, we came up with the idea for doing that. I mean, I had written the script with Kostav, so it was a good experience doing that as well.
I'd like to introduce another member of the jury who kind of who's joined us, albeit a bit late. Ramesh Kaul for many years with Mahindra and Mahindra as a vice president, and he was managing their gear division recently. So welcome on board, Ramesh. I think you have to wing it with this one. We've been through the breakout sessions with the jury members, so you can be free in your.
And Kavi, good morning and apologies for being late to everyone. Was this the first presentation or the second?
This is the first panel.
First presentation.
But anyway, I didn't miss the presentation. I saw the whole presentation.
Okay. So I'd like to first hand it over to Suprati to start.
Okay. So yeah, wonderful job, Team Scambots. I mean, you showed a little bit of the Python code. I mean, you just said this is our code. I mean, what are some of the you know most difficult challenges that you faced when you were trying to do this? You mentioned that it was going and hitting the wall or something, and then in the final part of the video you also showed the robot overturning or something. But my question was, what was the thing that really troubled you the most in getting this project implemented?
So defining the values of KP and the in the line following fast.
I couldn't hear you clearly. Can you please repeat that? Defining the value of?
So getting the values of KP and V in the line following.
That was the most difficult thing. Okay.
Yes.
You know, there were some right angle turns I saw in that line following thing, and I saw your robot sort of coming out of the line and taking a smooth round turn over there. So what was happening? I mean, how did you do that? Could you explain? It did not go to the end of the right angle and then turn. It sort of left the line before that and then turned.
Yes, sir. So we had defined a constant KP, which we are telling you as a reaction. So when the camera detects that it is in the white part, it tells the motor to move towards the black line. And so to move towards the black line, we have calculated this get the centroid, and there is a center. So we are seeing that what is the distance between the center and the centroid, then calculating the error value and using that error value through the PP controller. We are telling the robot to move towards the black line, and we have increased the KP to a higher level, so detects that it is in the white part, and it tries to get the black part.
Okay. So do you, I mean, suppose there was a really, a lot of zigzag in the line. So do you anticipate?
So sir, actually, what we first came up in the documentation that was earlier given to us, there was an approach to first crop the image, and then using the cropped image, you find the centroid value, and if it misses the line, was a separate code for that. But we generalize the code in our own way, so it will find the centroid automatically. So that's why it was taking those sharp turns that you were asking about. And
No, what I'm asking is that suppose I had a lot of zigzag in the line, how do you expect your robot to move there? Right? Suppose there is, suppose there's a Z line. Suppose there's a Z
Z line,
kind of.
yeah. So, sir, actually, what we think is, since the image, the whole image is calculating a centroid value, it will always try to move towards the next path. So, if you're saying the zigzag is like a Z, so it will also keep the next zag or the next line in with reference to the line which is traveling currently. So in that way, I guess the same code of ours would work on that scenario as well.
Okay, good. Yeah, so I'm done. Maybe Ajit or
So, Krish, think about that a little bit, because what might happen is that you are now hitting a line which is going in the reverse direction, not the same direction. You might overshoot it.
So, sir, there, I guess the P controller might do the job if it is overshooting. Maybe implementing the I and D parts of the PID might help, but yeah, as you are saying, it might sometimes overshoot as well. We have to check that. I mean, we were trying to make our own line following arena and then changing the files, but we
No, no,
haven't.
we actually made the problem easier for you by not having zigzag kind of things, because for that you'll have to have a different kind of algorithm. So maybe we should pass it here to Ajit Rajwade to give his commentary,
Maybe,
because I think
when if the zigzag path is given, maybe then I use a different set of sensors. Let's say I would use the IR sensors. If that's on the epoch or not, maybe I will go with a different approach there, because the camera might be problematic. It might be solved with the camera as well, but IR sensors in zigzag paths is a easier approach.
don't speak too soon. Ajit, over to you.
Okay. Okay, so I have. Oh, first of all, I'm hearing an echo, but okay. So I have a question. You know, you've run these robots in this environment, and you've trained the algorithm and its various parameters. Now, let's say you did it under one kind of lighting condition. You had, let's say, 3 tube lights in this room in which you ran your robot, and then you move to another room where the number of tube lights is different, or their intensity is different, or they're in different relative locations. Then what changes if you transferred from one room to another? Have you observed any changes to the behavior of your algorithm?
I guess yes, there will be certain changes because when we inside the line following, it will affect the most, because the wall following thing, it is just using the proximities value. But when it is in the case of line following, maybe playing with the threshold values and then setting a good threshold value in that room might work the line following there in the other room.
Okay. So, in your thresholds, you're putting threshold on what? What color space are you using for your threshold?
So for the threshold, what we are doing is there is a black line and the background around the black line is white. So what the thresholding is doing is it is making the black line white and it is making the white background black. So it is thresholding that way. So it's called the binary threshing.
Okay. Yeah, but there'll be a certain value, like beyond this, it is white. Below it, it is
Hmm.
black, right?
Yeah. So that thresh value was 210. So if it exceeds that thresh value, it is set to 255, which is white. Or if it is less than that threshold value, it is zero. That is black.
Yeah. All I'm saying is if it suddenly started raining outside in your
Hmm.
place, the lighting, or basically the lighting changes, then 210 will change.
It will change. Yes.
All right.
uh,
Another thing you were mentioning about a proximity sensor.
yes, sir.
So, can you just very briefly tell me the principle on which these proximity sensors work, or any one of them works?
Anish will tell that.
Yeah,
He is the
so
guy who did the hardware job for us.
sir, my name is Anish Kumar, and I am
Hmm.
handling the hardware components job
Yeah.
and about its implement. So, proximity sensor is basically a sensor that detects optic obstacles in its path without any physical contact in the real time, and it uses two components: IR transmitters and IR receivers. So IR transmitter is basically a IR LED which we have usually seen in TV remotes, and IR receivers are just a photo dialogue. Huh. They usually convert the IR rays into electrical signals, and thus we can calculate the distance by using the formula D equals to VT by 2.
So, do you understand this formula D equal to VT by 2? What is it?
Yes, yes, sir.
No, so can you explain a little bit about it?
So D2 is the distance which the ray is traveling from the transmitter to the receiver two times, and V is the uh, speed of the light, and the time is the time period.
Okay. So you're measuring the time.
Mhm.
Your sensor is measuring the time first.
So that sensor is actually what it is doing. It is measuring the time delay. So after the IR ray has sent and it has been received by the photodiode, we are calculating the time delay. So actually that is happening back end at the side of epoch. What we are getting the final output from the epoch is the distance. But we went deeper in understanding what the proximity sensor was and then how it works. So,
Okay.
yeah.
All right. I have no further questions.
Shall we move on to the next team?
Sure.
Thank you,
Thank you
guys.
so much, sir.
Thank
Thank
you
you so
so
much,
much,
sir.
sir. Thank you so much.
Yes, so the next is called Programmers of Encyclopedia. The team ID is 49. They are from Bangalore, BGS National Public School. The team consists of Chatresh, SM, Sanjay, and Kritin. So I'll take the video here. Just a minute.
Myself, Chetresh Ramsaipudi.
And I'll
I'm
speed
studying in
this
BG's
video up
National
by a
Public
bit.
in class 9. We are from the team Programmers of Encyclopedia and the team ID is 49.
Hi everyone, my name is SM Vedant and I study in class 9 in BG's National Public School. Our team name is Programmers of Encyclopedia and our team ID is 49.
Namaste. My name is Sanjay Shivakumar from class 9I from PJ's National Public School.
Namaste, and I am Kirtan as from class 9 and I am from BG's National Public School, and my team name is Programmers of Encyclopedia. Thank you.
Myself, Chetresh here. I'm from team Programmers of Encyclopedia and the team ID given to us was 49. And here, as you can see, there are two walls that it has to sense and yeah. So how this is going without colliding with the walls, I haven't set it like go straight for this much time and then here you just set this wheel velocity to this much and then I haven't hard coded it. Like it changes according to the situation. I've used proximity sensors here. I've used two sensors, this one, and I call this PS1 and this one PS6. And how it basically works is a pre-controller or a proportional controller, which basically means that if I've said the ebook that this is the distance it is supposed to maintain from the wall, and if it's far from it, it will turn this side, and if it's near, then it will turn this side, and it basically calculates according to that. I've even set the proportional constant, and yeah, it basically computes what velocity does should this have and this will have. The reason why I've used two sensors is we might come across a situation like a hairpin bend where one sensor, maybe this PS6 sensor might not be able to
Is
sense the wall. The wall might be out of
something
the range of
happening? I
this
can't
PS6.
see anything.
And at that time, it might need the help of PS1 sensor. And vice versa. It basically, it can
Hello.
be anywhere. Because now this is, for this situation, I haven't written like that. It can be any situation and this will work. Because I haven't hard coded it. It will change its velocities according to the situation. And For now, if you use only PS6 or PS1, that would work absolutely fine till here maybe. But here, there comes the problem. The sensor, the PS6 sensor, when it comes here, it might be going like this. Then it will think the wall is way too far away, and then it will start going straight. And then when it realizes, it just gets confused and then collides with the wall. Then it will need the help of this sensor. And that's why I used two sensors. And yeah, even here it will need the help of PS1 sensor, because even PS6 sensor is somehow confused at this point. Yeah, and in code I've written the same thing twice, but it's not exactly same thing because the values vary and some divisions or multiplications vary for PS1 and PS6. I've tried to combine it into just one function and call it twice just to optimize my code, but then I was somehow not successful. Yeah, but yes, it still works. Although it's long, but then it's fine. It works. It works absolutely fine. And yeah, what I've also done is that if in normal cases, it just takes the average of both the sensors' velocities. For PS1, it says this wheel should have this much velocity, this should have B velocity, and this one A. This might say C, and this might say, and this should be D. What I have done is A plus C by 2, and then B plus D by 2. But then there might be cases when PS1 sensor says that the ebook should take a very sharp turn right now, or else it will just go and crash with the wall. Then what I've done to handle such situations is I said that if, according to PS1, if it says that one velocity is very less than the other one, which basically means it needs to take a sharp turn, then you listen to PS1 sensor rather than the PS6, because PS1 is really important and very urgent right now, and vice versa for PS6. And now, as you see, yeah, see, this doesn't sense this wall, where it will need the help of this one, or else it would have just gone and collided with this wall, because it doesn't know. It just depends on this sensor value. It still says that the wall is too far. It doesn't sense this one as we have thought before. We could have used this, but then this also has its own drawbacks. I felt using two sensors on two sides would be better. But then yes, we could have also used a combination of this sensor and this sensor. We could have said to follow this one, but then if this sensor senses some danger, then it should turn immediately. That could work, but then I felt somehow this was more efficient. And yes, I've also, as I said before, if it senses a threat or a wall very near, which basically means if the sensor value is less than 20 or very near, then it has to take a very sharp turn, very sharp and very fastly and very urgent. It doesn't have time to think. So in that case, I asked this wheel to do nothing, and this wheel to do a lot of work. It depends on the sensor. If it's PS6, then it does like that. If it's PS1, then it is the other way, which means this will be set to 0 and this will be set to 6.28 millimeters no, radians per second. Yeah, as you can see now, it senses some thread, it senses ball here, so it just turns really sharply. And 6.28 is the max speed of this epoch. And yeah, this is how it basically works. Actually, according to the algorithm, we shouldn't need a second sensor and sensing like if it's less than 20 and all, but then yes, it isn't always as we think in the real life. And this is by the way stimulator, and if it's real life, then we might even face a bigger problem. But then yes, for now this works absolutely fine, and I hope it works for any other situation, like any other wall following problem as well. And now comes the main thing, to switch between line following and wall following. So what I've done is I asked it to take a frame or just a line of pixels and check if it sees more of red than the blue and green. And how computer understands is just in blue, green, and red, BGR. Actually, it's supposed to be RGB, but then OpenCV model that I've used for Python coding, it understands things as BGR, the colors as BGR rather than RGB. I don't know why it does like that, but then yes, that's how it is. And yeah, once it senses red, I just asked it to go forward for 2000 millimeters or radians or whatever, and then switch to line following, because I just hard coded it, because in red it might get confused with the line following. And yeah, you if you have observed, I've just disabled the sensors right now. Before it was red in color, and now it's gray or white, however you feel. And I've disabled it because it's just waste. We don't need this sensor anymore now, because we've just come into line following. Yeah. And now how this line following works, it's also very much similar to wall following. It's also a proportional controller. But then over there we had proximity sensor to sense the distance from the wall. And here we need something to distance, measure its current position from the position of the line. And we are using the camera that the eBug has built in. And here I just take this frame. Why I take only this much is because I don't need the other part. So it just wastes lots of time and too much of processing for it to check, and it makes the program much slower. I didn't want to do that. So what it basically does is it will find the center of this black thing, and then it checks the distance of it from the center of the frame. And if those two are on the same point, it basically means that it's going straight, because when it's going straight, then the line will be very much, perpendicular to this one, and it will be really straight. As you can see now, it's correcting it from 4, it reduced to 3, then 2, and now it will come back to 1, and now 0. And yes, it will fluctuate between 0 and 1, and this 1 and 0, it basically means 1 pixel or 2 pixels. Okay, yeah. So this all works fine, but then when it comes to this point, this right angle turn, it really gets confused, because this line comes perpendicular or parallel to the camera, which confuses it. It says, I don't know what to do, you didn't say me anything, and then it just stops. But then to solve that problem also, we've got another solution. As you can see here, there's something saying previous error. What it's doing is that it's saving this one in this variable. Why I'm saving it is if it senses nothing. So what basically happens here is that it will sense this centroid, and then it will turn. But then when it turns, the line just kind of goes out of the way of my frame or whatever, and it says just white. It doesn't see any black to find centroid, and then it says I'm blank. So what I've said is, if the previous error is negative, then you turn left or right. And if it's positive, then you turn right or left or whatever. I don't remember it properly, but then yes. So that's how it works. Yeah, and how it turns is, I've set this to minus max speed and this to plus max speed, or the other way around according to the direction it is supposed to turn. And yeah, and how it senses the centroid. Coming to that, I first convert this whole image to grayscale just to make it much more black and white. But still it will get confused because there are many shades of grays. To simplify that also, I just said it like, if the color or the intensity of the pixel is more than 120 or whatever value, just make it 255, which means white, I guess. And then if it's less, then make it 0, which basically means black, if I'm not wrong. So, which
Rishi, would
basically
you
means that
answer?
the whole picture will be represented in just two colors, that's white and black. Anyways, here mostly everything is just white and black, which you don't need to worry about. But then you will need to worry when you come one balls comes in the picture. This is people will be able to see the red ball. When it does the, and yeah, when you make that into black and white, that's basically called thresholding image processing. And yeah, when it says this red ball, it says, I see two lines here. For that, I written something like, if one line is bigger than the other one, then you just follow that. But here it's wrong. This isn't the line. This is a ball. So what do you think? You will see whole black and then it finds the center and then it goes starts going towards the ball. So how I done what I said is that, yes, although you can't visually and basically you need to sense red, but then in real colors you can sense what is red and what's black. So when I said, if you sense the red color second time, if it is what was the first time, then it is in the tunnel. It basically means it's in the tunnel, and then it has to go straight 2000 meters and then switch to line following. But if it's sensing the second time, then it basically needs to turn just like that. And yeah, when it turns, it automatically catches the line. This small part doesn't, and so it goes happily. And how I've said it, like this is the second time and this is the first time, is that I've assigned a value, a variable called toggle, and it has boolean value, why you call it true. And when it's true, I've said it that it's in red tunnel. If it's false, it basically means that it is the second time it's seeing red, and this is the only possible way you can see the second time red. Yeah, so this is how it works. This is my algorithm, and thank you.
So thank you, Team 49, for your excellent video. Stop sharing my screen right now. One point to note here is that their video was a bit lengthy because their computer did not support like the simulator going at real-time speed. So if you've noticed, their simulator was operating at around 0.15 to 0.1 times the real speed. So actually the run is pretty fast, but actually the run is pretty fast, but yeah, but despite due to their hardware limitations, it took a long time to record. So excellent work, Team 49. So
Yeah, Rishi, who's that disturbing you in the lab?
it is Kiran Bhai over here. Say hi. Hi.
Okay.
And Bhuvna Madam as well. So no worries about that. So yes.
So what is the team name, Rishi? I missed the initial part.
Sir, it is Programmers of Encyclopedia. Team, if you're here, please unmute yourselves and unmute your
Yes, sir.
Yes, sir.
Am I visible?
Hi.
I'm getting a flashy video actually, which is flashing and not steady. Yeah, I see Sanjay Shivkumar. I see Chatresh here. Who else is there?
Kirtan and Vedant.
Okay, please explain what is this problem that you had with the simulator?
Sir, I actually don't know what it is, but then it says only 180 seconds, but then in real time it's taking around 20 minutes to complete the whole stimulation.
So it's almost at 1/10 the normal speed. Is it because you had a very old laptop that you were working on?
Yes, sir. Yeah, this is kind of slow.
So how did you manage the computer resources between yourselves? Is it one person who had the computer and you would all share it, or what?
No, sir, we all had different PCs with us.
So who would be responsible for running the simulator?
So, sir, Chandrasekhar,
Sir, me.
he had a powerful assistant.
Who's that?
Sir, it
I
was
didn't
me.
hear. It was you.
That was
Okay. So can you explain what happened at the end when you were almost reaching the finishing line and your robot began to just turn and
Yeah.
circle? What was happening?
Yes, sir. So actually, what was happening is that Titan and all, when we fixed, like when there were two types of line following tracks which was given actually, and in the track shown in the video, the thing what is happening is that it's sensing the red wall, and then it's thinking that the red wall is also a line, and rather than sensing the black line, it's thinking the red line as the black line, because of I should have played with the thresholding values, but then because the red line is bigger, it thinks that is the line, and then it goes towards it, and then it eventually goes out of the world. So what I've done is like, if it senses red color the second time, then I've asked it to turn take a hard turn. I put some 1530 milliseconds. Yeah.
So this was a bit of a jugaad that you did to make it work, right?
Yes, sir.
Okay, I'll pass the floor over to Professor Supratik here.
Yeah, unfortunately, I missed the initial part of the presentation because of some browser issue. But I think it's a very impressive presentation you showed, and the last part. I mean, while one can call it jugaad, but I think also it's improvisation. I mean, when you see unexpected things happening, then you also need to improvise. So my question to you is, so how did you go about, I mean, for example, this issue that you just mentioned, right, that it was detecting the red line as black line as something. So how did you go about finding these corner cases that everything is running fine, but there's this one corner case? Or I mean, is it just running it on the simulator and then you see that it's having a problem, or did you have some initial thoughts, initial discussions on these could be the problem cases, and then let's see what we can do about those? So
Uh,
how did you go about identifying the corner cases? Corner cases, by that I mean the difficult situations, not necessarily the corners of the track. Yeah.
Yeah. So, sir, actually, it was already said to us that we will face a situation like this, that the epoch will get confused with the red wall in a live session. So, yes, afterwards, we tried to fix it by sensing the red color and asking it to turn.
Okay, but I mean, did you do some kind of testing to sort of give all kinds of strange things, maybe which are within the specifications, to see how your program performs, how your robot performs? Did you do any kind of testing of your code?
Uh, I actually
Did you
didn't
test
get
your
your
code?
question, but then I've
Pardon?
just asked the I'm using cv2.iron to show the scene and mark the centroid. So I'm just checking if it's finding the centroid correctly, or is it getting confused with any other thing. Like in the starting, I faced a problem with line following, was that actually it wasn't sensing the centroid of the black line, but then it was sensing the centroid of the white line, which I got to know when I started showing and marking it. And then what I did was I just inversed it. I used binary thresh inverse to just invert it. Like, yeah, it was finding the center of the white color. So what I did was I just made white to black and black to white.
Yeah, so I'm actually asking a different question. I'm asking that how did you go about testing your code? How did you, I mean, you would test your code by providing some corner case inputs and then seeing how your code is behaving. I mean, did you do any of that, or you just said that uh, let's just run it on the full simulation thing?
Yeah, sir, I just run it on the full stimulation thing.
And then whatever problems you see, you fix those.
Yes, sir.
Okay. Okay, so that is certainly one approach, but I mean, if you want to scale this effort up, like I told you at the beginning, that the Perseverance rover just landed on Mars, and you don't have an opportunity to go and fix it now. Like it takes 7 months to reach Mars from Earth. It takes flight 11 minutes to reach from there. So it's necessary to actually proactively think about all that can go wrong
Yes, sir.
in an environment that you may not have seen before, and to sort of do some testing based on that. Okay, so the next question I have is uh, this whole thing that you just demonstrated, right? Which part of it actually required improvisations, or basically doing a little bit of hacking uh, with the hardware components rather than with the software components? I mean, was there some part where you felt that okay, we need some more, maybe getting the data from the hardware in a different way, or getting, yeah, because not everything is just software. This is a interaction of hardware and software. So
Um,
who among you were dealing with the hardware, or all of you?
sir, all of us.
All of
Like,
you? Okay, that's excellent. Okay, so were there any issues that you uh, had to face with the hardware where you thought that some interfacing was not going right, something that you
mm,
wanted?
nothing like that actually.
So everything was just fixable in the software itself.
Yes, sir.
Okay.
We didn't actually had to think much about the software.
But which would be the kind of critical hardware component in what you have done, where errors or malfunctioning would really cause a big problem? Did you
Mm,
calibrate the sensors? Did you do any calibration of the sensors?
Supratik, I might add that this entire theme was done inside a simulator.
Oh, I see. So they actually didn't deal with any hardware itself.
They didn't deal with the hardware. The sensors were all simulated ones. So they had ideal lighting conditions and sensors that worked as they're meant to work, and not the
Oh,
usual problems that they have with real hardware.
oh, I see, I see, I see. Okay.
So, sorry, Kavi, sorry, Supratika, I want one
Yeah.
clarification. So, this was not an actual physical environment where they ran the robot,
No, no, this was in a
was it?
simulator.
Okay.
The whole thing was in
Okay.
a simulated environment.
Okay.
Okay, but suppose this was not a simulator. I mean, this is just a question going beyond what you've just done. I guess this year we had this coronavirus thing, everything is virtual. But so, which of the hardware components would you really be worried about that errors there would?
maybe, maybe the proximity sensor itself.
Hmm. And I mean, do you have any idea of how to make sure that it is really, because sometimes the value that it gives may not be exactly the right value, right? So do you know how calibration is done of sensors?
No, sir. Like,
Okay.
this is like the first time I'm doing things. So,
Okay. No, no, that's very impressive. What you guys have done is very impressive. But when you deal with a real sensor, the first thing that you do is calibrate, and because it might tell you that something is 2 centimeters away, but it might actually be 3 centimeters away. because there might be some, you know, some register there which is not correct, or some signal which is not getting uh, received properly. So the first thing you do is calibration, that I have read this value and this is the actual value and this is the relation between them. Okay.
So actually, we
Go
haven't
ahead.
come across all this because everything the epoch does, and then it just gives the sensors values. So we,
Yeah.
we don't have much idea about how it does all this stuff and things. So we just got the value and then we use the value. That's it.
No, no. In fact, Supratik, I might add here, we were surprised as to what the children achieved, even with what we have. In fact, the next phase of the competition should be maybe, or the next iteration should be, once they've done this on a simulator, we take them into a real robot environment, and that's when they'll start hitting all these problems.
Right.
Right. And that's when they'll start thinking about these problems, because they don't know about these problems that they even exist.
Right.
Yes, sir, exactly. I'm
Okay.
hearing
Yeah.
this for the first
Yeah,
time.
Kavi, you've been having this real environment, right? Like I remember those competitions used to have in
No, no, no.
AMCC.
No, that's in the main the engineering student thing. But this year, because of COVID lockdown,
Yeah, obviously.
we
Yeah.
were uncertain of the hardware supply chains and all that. So even in the real competition with the undergraduate students, out of 5 themes, we have only one theme which actually uses hardware. And this year we've gone to a different level. We've taught them how to use FPGAs. So they're doing image processing, writing VHDL code on FPGAs. Right? So they've gone to a very interesting level. But here, since we are just dipping our toes into the water of what school children can cope with, this is, I felt, itself quite ambitious. And the kids have done us proud, I feel.
Absolutely. Absolutely.
In fact,
Okay.
in the interest of time, well, Ajit, with your permission, can we move on to the next team?
I'm fine because I had similar questions as Supratik had. We can move on.
Okay, will do. So we'll have you lead the question in the next.
Yes. Maybe Ajit can lead the
Yeah.
questions next.
Okay. So over to you, Rishi, to play the next video.
I think just before that, I just wanted to add a point about simulator versus hardware. All of this was done in 10 weeks period, and I don't think it would be possible to introduce image processing and control systems and kinematics, all of that concepts, and be able to complete it in 10 weeks. It made it possible because it was easy to do in simulator, I guess. But if we do switch to hardware, then we'll have to expand accordingly. So yeah, with that point, I guess.
Good afternoon. My name is Delzan Barucha and I'm from grade 11. I study at HUB Global Academy. Our team ID is Team 66 and our team name is Team HUB.
My name is Shivani Kulkarni and I study in grade 11.
My name is Junaid Edia and I study in grade 9.
My name is Jian Jain and I study in grade 9.
Good evening. Welcome to the demonstration video. For this task, we have split up the code into wall following and line following. So as for the wall following section, we've used proximity sensors 1 and 2. We've then calculated the distance. This inverts the range so that 255 is greater than 10 centimeters and 0 is 0 unit. This is more intuitive as a higher value represents a further distance. We then calculate the error. As we are following the right wall, in this case, as we're using proximity sensors 1 and 2, a positive error means the robot is too far left, while a negative error means that the robot is too far right. We found the maximum and minimum errors you practically when we set the velocity to 0 and then move the robot accordingly. This allowed us to make an appropriate KP value. We then find the turning velocities, which is omega 1 for each proximity sensor 1 and 2. We average them. This is done so that it increases the robustness as well as it allows the robot to turn appropriately during sharp corners. We then cap the velocities to make sure that they're below maximum speed. An advantage of capping the velocities is that if we have a greater Kp value, which causes the omega value to be high, the velocities might reach greater than 6.28, which is the current max velocity. This allows us to have a greater range for the omega values, as the omega values can go lower due to the high Kp, however, do not exceed the maximum speed. If the error is nearly zero for both the sensors, then we make the left and right velocities to go at its maximum speed. As for the line following section, first we have a function called color check. This takes the image from the camera and finds the average amount of blue, green, and red in the middle row of the camera. This is done by cropping the image and then finding the mean, which is the average. We then find the difference between the averages of green and red and blue and red, and then check whether they meet a certain critical value, which is diff thresh. If they do, which means that red is present in a large quantity, then the bot mode is set to line follow and the bot mode return. Otherwise, the bot mode does not change. This ensures that once the mode has been changed to line following and the red area has been crossed, the bot mode does not change back to wall following. As for the line following section, we find that if when it does successfully switch, we find the centroid of the image, we crop the image, we then convert it to HSV, and we using the two variables black lower bound and black upper bound, which are numpy arrays storing the HSV values for black, we create a black mask. Why we do this is so that no matter the background of the image, as long as the line is near black, which is why we add the range, it is effectively thresholded. So no matter the background color, it's always going to find the line. We then find the contours of the line. We find the contours of the image. We check the length of the contours. If it's greater than 0, which means contours are present, then the contour maximum area is taken and the moments are appropriately found. If the appropriate moments are present, then the x coordinate of the centroid is found. Otherwise, an untype object is returned. This is used in a check later on, as you can see here, where if none is returned, then we print that the centroid x value was not found. Otherwise, we continue. As for the continuation, we make the epoch move by using a P controller, which is similar to the wall following. However, here the error is from the distance from the center of the image, the center x value of the image, to the centroid x value. Again, we cap the velocities to make sure they don't exceed maximum speed, and this also helps for the KP values similarly. If the error is nearly 0, then we got max speed. This decreases the amount of time. As if it's straight path, then we got max speed. As for the main loop, we check for the bot mode by using the color check function. If the bot mode is wall following, then we get the values of the proximity sensors and the wall follow section of the code is executed. If the bot mode is line following, then the line following section of the code is executed. Otherwise, if somehow an incorrect bot mode was inputted, then we print that an undefined bot mode was set. One of the difficulties we found was mainly decreasing the amount of time. This was, however, overcome by adjusting KP values appropriately. Thank you.
What I liked best about this competition was that the tasks were not very difficult right at the beginning. They increased the difficulty in steps. And I also found the live interactions and the learning material provided to us very useful because, like I said, the learning process was difficult for me.
Life-changing experience slash eureka moment or overcoming certain major challenges. One of the major challenges that we faced during the competition was debugging the code. I realized that every single slight change you make in the values can cause major changes on how the robot behaves. Another obstacle we faced was understanding the math behind some part of the code. This was specifically seen with task 2, where tracing the semicircles accurately required a decent amount of math. This, however, made completing the task even more rewarding.
I found it difficult to set aside time in the day to do the tasks, and I also found learning the material a little difficult. But what was actually the most challenging was troubleshooting my code and finding out what was wrong so that I could get it to work.
Any change you see in yourself and the impact of eYSRC. So one of the main changes that I see in myself is that I'm able to code and more importantly troubleshoot my code much better than before. Along with this, I also learned how to effectively comment and present my code, and I realized the importance of this as it makes it much easier to debug. In conclusion, we definitely learned a lot from these competitions in terms of coding, robotics, and other concepts like image processing, which we frequently use in our lives, but we don't realize it. The competition gave us a glimpse into a lot of interesting concepts, and in the end, we all enjoyed overcoming the challenges we faced and interacting in the live sessions. Thank you.
So
Ajit,
yes,
over
that
to you.
was the
But it's quite interesting that many of the points that the youngsters brought up are right up Supratik's alley to do with code safety, reliability, and stuff like that. But I'll pass the floor here to Ajit, please.
Yeah. So, first of all, thank you very much for your presentation. I'm not able to see your videos. It would be nice if your videos are on. Yeah. So thanks a lot. This was a very nice presentation. So one thing that I observe is, when you're doing the line following, whenever there's a right angle, your robot tended to follow a curved path, which did not follow the line temporarily, and then it got onto the line after that. Am I right?
Yeah.
Yeah. So can you throw some more light on that? Why did it sort of tend to miss the line and then it got back on track also? So can you explain both these things in a little bit more
Yeah.
detail?
So what happened is for the right angled areas, we had two options. One is we detect that it's a right angle, and then we do an exact 90-degree turn. Or what we chose to do was that we took the part of the right angle and it turns beforehand. So we crop the image in such a way that it actually looks ahead of the line. So it sees the right angle and it turns ahead of time. That's why it didn't exactly follow the line and it went ahead of time. So that way, it even if it doesn't overshoot the line because it's a sharp turn.
I see. So you think, suppose you had decided to very rigidly follow the line, and at the corner you thought that it may overshoot. Is that what you think?
It might overshoot it because there's a sudden curve. That's what I think. Yeah.
Okay, but then you could have got it back on track, right? So you could have overshot a little, but you could have recovered. Right now, anyway, you undershot and you recovered. So I'm just wondering whether there you see any advantage of undershooting over overshooting.
If you undershoot it, the line's still going to be in view. If you overshoot it, it'll just be a white screen. So.
Okay.
And we made a condition that if it is a wide screen, it just does what it initially was doing. So let's say it slightly overshoots it, but it is turning and it detects a white image. That means that it will keep turning. It won't just give an error that way.
Okay, but I mean, this is wonderful. I'm just wondering, there may be applications where you do not have the luxury of going off the track. This case, it was fine. Just a comment. All right. Another question I have is that how would you deal with lighting changes? Because right now you didn't have to worry about lighting changes, but in a real situation, you would have to worry about it.
Yeah, so the lighting changes will only affect the line following section because the wall following section uses the proximity sensor. So I don't think that will affect it. So as for the line following section, as I mentioned, we converted the image to HSV, and then we checked, we kept the range for the lighting value, which is from 0 to 80, and we thresholded it using that way. So we, as long as the line is black in color, even if the lighting is dim, the line will be very evidently contrasting to the background. So it will be able to still detect it.
Okay. So HSV, so I have a couple of questions now here. HSV has 3 values, right? So whereas you're putting a threshold on one value. So can you elaborate a little?
Yeah, so we set the range so that if the hue or saturation can range from 0 to 255, as long as the value range, lighting value ranges from 0 to 80, it will still be considered black. So we actually went on a HSV color picker online, and we set, we noticed that any hue or saturation value, as long as the lighting value is low enough, it's still considered as black for the line.
Okay, I thought your lines were red. I may be missing something here. Your lines were deep red, whereas you're talking about black lines. So I'm a little confused.
Yeah, it was very, very dark red. So that's why we set the range for the lighting value from 0 to 80. So even if it's a very, very dark color, it will take it as a line.
Okay. All right. I have one last question. Okay. Well, I have two questions. Okay. So you are a team of 3 people, right? But I see only 2 of you.
We're a team of 4 people. One of
4
us
people.
couldn't make.
Okay. All right. That's fine. Okay. So do you know what is an interesting property of the hue in an HSV space? Something very interesting about the hue. Do you know what that is?
No.
Okay. No worries. Don't worry about it. It's fine. You may want to look it up online. Okay. The hue has a few very, very interesting properties, particularly from the point of view of illumination invariance, making things invariant to a large variety of lighting conditions. You may want to look it up, okay, for future reference. All right. Okay. So I'll not tell you the answer. You can let me just arouse your curiosity a little bit. So yeah, I'm done with my questions. Thanks a lot for answering and for your presentation. It was a lot of pleasure to watch.
Thanks, Ajit.
Thank you.
Supratik, with your permission, we'd like to move on to the next. Otherwise, we'll be way back on time.
Yeah, absolutely.
Okay. So next, please, Rishi. Thanks, guys. Nice work from the students of HVB Global Academy in Bombay.
Hi, sir. Can I, Kavi, can I shoot just one small question?
Yeah, please do.
Yeah, so it's a very simple one. How did the class 11 guys, the 2 of them were class 11 and 2 of them were class 9. How did their experiences differ in going through this project?
Well,
can you hear us?
Yeah.
Okay, so
yeah, I'll read myself. Sorry.
Yeah, Delzan, we can hear you. In fact, perhaps I should give the chance to Shivani here to respond. She's also class 11, right?
Yeah.
So how did you work with the 9th standard quote unquote bachas? I don't see them online.
Well, I'm not, well, I mean, I don't think it was very difficult for them. I don't know. I mean, I haven't really asked them how difficult the competition was for them. So maybe we should ask them. But
Are they there?
I think one of them is here. The other one didn't manage to make it.
So maybe he can answer.
Yeah, can we hear the one who's there?
Yes, I'm here.
We can't see you. Jian, right?
So I have really terrible bandwidth right
Can't
now,
see
so
you.
turning on my camera wouldn't really help.
Sure, go on. Yeah, would you like to answer the question? How was it working with the seniors?
So actually, it was quite interesting because we didn't have that much experience in in the coding field, but they did have experience. So wherever we couldn't find out the solution, they helped us. So it was good.
So how did you divide the work?
Can I answer that?
Sure, go on.
Because I was the main person who divided.
Okay, go on.
So overall, we didn't exactly segregate it as roles. We just all did everything that way. So what happened was the Shivani and I, who are the 11th graders, we have done Python before, while the ninth graders didn't. So the entire programming was a new concept to them, while we knew the basics already. So it was quite. I think it would be quite difficult because obviously I remember when I learned Python first time, it was quite hard for me. But luckily, Python is a relatively readable language, so it was better that way. So as for the work, mainly reading the comments and proofreading was what we gave them, and obviously the logic beforehand. So determining the logic. So we made flowcharts initially for the task three. So in that way.
Okay, so they acted in a role of validating what you guys were kind of coming up with.
And thinking non-code wise logic. So not actually the coding part of it, but how we are going to go about solving the problem.
Okay, will do. Thanks. So over to you, Rishi. I hope, Romesh, that's answered the question.
Yeah, I'll reserve the next one for later. But for example,
Sure.
the group before I forget the name. What the name of that team was, the second one actually. They were all younger kids. Huh? Some of them were like straight from a school classroom with a tie and everything. They all looked
Yes.
like eighth, ninth graders to me.
Yeah.
I am keen as a student of people and as a student of human beings, because I have very little to do in terms of contribution to robotics and IT personally. I'm a user, an application user, but I'm not a person. I just want to see how excited and how they felt in the whole process. But I reserve that such questions.
I think, Romesh, your question will be answered by the next team, which is a team from Countryside International School in Surat.
Okay. Okay.
So I should say that Romesh was commuting for many years to Surat, where he ran a company that makes gears.
Rajkot,
for
actually. Gujarat in general. Yeah.
Rajkot, nearby. So, Rishi, over to you, please.
Yes, I'll just straight away play the video.
Hello everyone, I am Tanmay Bagadia from Countryside International School, currently studying in grade 8th. Our team name is CS Tech Minions and our team ID is 109.
Hello everyone, I am Vansh Barfiwala from grade 9. I am here from team ID 109 and team name CS Tech Minions.
Hello everyone, myself Dishita Singh from Team ID 109, Team CIS Tech Minions.
Hello everyone, I am Riva Raval from Countryside International School studying in grade 8. My team name is CIS Tech Minions and team ID is 109.
So now it's time for the code explanation. So let's start with the simulation. Step is the wall following, then the transition between the wall following mode and the line following mode, and then we have line following part. So in the wall following, we are using only one distance sensor, which is PS6 sensor, because only one sensor is necessary to do this task. In the wall following, we have the PS6 sensor whose like the readings ranges from 0 to 255. Then we have one variable called distance inverse, which basically stores the PS6 value, and we have the distance, the actual distance, which is subtracted from the max distance and the distance inverse. So that basically we get the idea of the distance between the wall and the robot. Then we also have the minimum distance and the max distance, which is basically how much the distance is between the wall and the epoch. So we are setting an imaginary distance which keeps the robot in the center. And then we have the error, which is the difference between the actual distance and the imaginary distance. We are also finding the maximum error so that we can use it in our KP. And our KP is used in the turning velocity of the epoch, and we have the average velocity which is set to be zero point 0.8 into the max speed. Then these things were actually for a cycle model. Then we are converting it into a differential drive model so that the epoch can actuate on the basis of it. We now have a very like you can say if or else, but here we have two ifs which are basically the caps for not exceeding the speed of the robot. So like this our wall following part does. Now after some time there will be a red zone. So for the red zone we are having a crop frame. First of all we are getting the image from the camera, then we are storing it in a variable called frame. Then we are cropping the frame because it will make our code faster, and also it will avoid the unnecessary obstacles between like the in the arena, such as the red walls. So like that we are having the red line following mode. It is basically line following only, in which we are giving a threshold value of the line, and on the basis of that our epoch is actuating. And also we are applying the P controller here so that it is working as a cycle model, but we are converting it into a differential drive model later. Now in our line following we are converting it into a grayscale, then into an binary image. Also we are inversing the binary image so that if the background of the line is white, then it will actuate on the black line only. Then we have the normalized error, which is equals to the error, and the error is taken out on the basis of the centroid of the x coordinate. And then after all the things of the moments and finding the contours, we have our P controller, which is basically same as the wall following and the red line following code. But here we are setting the KP as a maximum and the velocity also as a maximum, so that we could complete the task faster. And here the main point in this, if the line is not visible, then what we are doing is, if the left speed of the left motor gets higher than the right speed, we are then taking hard right turn, and vice versa for the if the right speed is getting more than the left speed, so that it takes turns, and then if it detects the line again, then it follows the line. So like this our code is. Also the main thing about the code is we have converted the code into three modes. One is the red line following code, wall follow mode, and the line follow mode. And we have a total five functions. One is for the hard turns, and the other three are the line following, and the wall follow.
Go deep into it.
We have faced many issues while completing our task. Like myself, I was not able to practice on keyboards and myself. We need to meet on Zoom. Myself, I was not able to practice on keyboards and write code by myself. We need to meet on Zoom, and like it was very much time consuming. We were always in very tight situations, and we were badly able to handle that. But there was a main obstacle which came was the COVID-19. Because of that, we were not able to meet often. Sometimes because the deadline was on the way, we met on someone's home. But taking all the precautions, we were glad that the eYantra team, they helped us every time. And being not able to practice on VBots, I helped my team with the coding part.
And in 1 week, our exam were going on. So at that time, we faced a lot of trouble by meeting. So our task was not completed before deadline, and this is how we our schedule was not managed properly.
Every time we faced problems, eYantra team was always there for us in live classes and even on Piazza. On Piazza, even other teams helped us very much. And we can also say that eYantra taught us very much about the real life problems and robots. Even the bonus task, it was a truly a real life problem because we had to design the arena by ourselves and the code was also to be given by us. So that was a major thing which helped us to understand real life problems.
The MOOC's classes were never in vain. First, it always helped a lot, but the main obstacle in front of us was the race. Between the scheduling and timings, the tasks as studies were also important.
Because of the MD book made by the eYantra team, we had a lot of clear idea about the tasks because every complex and compulsive tasks were, they were very complex for us to understand because we were truly a beginner in this line, in this field. So the MD book, which was created by the eYantra team, was very helpful for us because it gave a clear idea of what we needed to do. And also the live classes which we had also like it made us understand the topics very well, and they solved many of our doubts in both of these places, in the MD books and the live classes.
Yes, so those were the folks from Surat. And
Floor is open. Supratik, Ajit, Romesh.
Yeah, maybe Ramesh didn't get much of a chance to ask questions, so he should go first.
Romesh. What
Okay,
standard are each of these students?
Sorry?
Sir, we are in 8th grade
Eighth and
and one of our team member is in 9th grade.
So I am terribly super excited to hear eighth graders talking code and everything. And I don't know what the basic inputs have been, but for example, the guy, the young kid, Tanmay, the glasses, Tanmay, were you the one who said you used to help people with the rest of your colleagues with code? So,
Yes, sir.
okay, is the standard in Surat such that code is taught in eighth grade?
Sir,
Or do you learn
basically
it?
there is one new guideline for the CBSE that now they are like starting to teach sixth graders also coding. So like I had a very basic experience. I know the advanced UI also, but for the Python I learned from eYantra team only.
Okay, I lost your audio in between, but uh, what were the, of course, besides the COVID and besides the fact that you couldn't meet or that you had exams and so on, what from a technical standpoint, I won't call it technology because too heavy a word, what from the technical standpoint was it that challenged you people? For example, just one example where you had a sleepless few hours or night, all four of you, young kids, uh, not sure about how to move forward. What was that one problem which bothered you?
So like first of all, my laptop wasn't able to handle the VBots only. So like I usually needed to wait for my teammates to move on, and because
No,
of
no.
that, like
Sorry to interrupt you. That is still an infrastructure thing. I'm talking about the project per se, Okay, you had an infrastructure problem, and I hope you will fix that infrastructure. You will have a laptop and the necessary, software to run the pieces that you want to run. But in terms of a technical problem to solve, no, I remember you said you had defined five kind of modes: wall following, line following,
three modes.
three modes: wall following, line following, and there was a third one. What was the third one you said?
Red line following.
Red line following. Uh, so, problems of this kind. I mean, were there any time when you got stuck and couldn't do without giving
Yes.
eYantra a call and asking, "Hey, Mr. So and so," or just one simple quick.
Sir, so like
Okay.
we faced many issues. In the first one was in the like the transition part only. Like we were not able to go past through it. It was just crashing in the wall. So like we took the help of the eYantra team, and then we were able to like pass the red zone. But then came one most challenging part in the line follow was when the line was not visible for the robot. So like for that I needed to came up with the solution. So like it took much time. So that also like I asked the eYantra team. So they gave me a hint and then I worked on it. So yeah, it went pretty well.
Okay, good. Thanks. I'm done.
Yeah, Supratik.
Yeah, I mean, very impressive stuff. What you guys showed. Uh, following up on what Ramesh said. So, this Python coding, you said you just learned it after this project was announced, right? I mean, you learned it from the eYantra team. You hadn't coded in Python before.
Yes, sir.
Okay. But did you code in some other language before? What was the other language you coded in?
Sir,
Yes.
it was basically the web development, HTML, CSS, and JavaScript.
But any like programming language for computation, like C++, C or Java or something heavy.
No, sir.
So this is your first time you're really coding something to sort of get a computational task like this done, putting everything in a while loop and then in every iteration determining what the next step should be and all of that. This is the very first time you're doing something like this.
Yes.
So and this didn't present challenges. I mean, I'm extremely impressed. I mean, this we teach our first years over one full semester, and then not all of them are able to make it. So, I mean, what was the most challenging part? I mean,
Professor,
for
the
example,
standards seem to be changing.
pardon me.
I said, Professor, the standards seem to be changing, evolving rapidly.
Yeah, yeah, yeah,
Good sign.
yeah,
It's a
very
good
much.
sign for the country, good sign for the kids.
Yeah, I mean, for example, you're writing a loop, and then are you worried about that some exception condition might arise in the loop, and the program might say? I mean, did you have Python crashing? Some trace showing up when you're running the Python.
Yes, sir. So like
Okay.
there were many errors such as the float division by zero, which
Mm-hmm.
was at the last of the task.
Hmm.
Then also the main error in the Python is the indentation error. It
Yeah.
just like dries up my brain.
It's a pain, right? I mean, why it's hard to believe why they did such a thing. Um, but so you said division by zero, you encountered this error, right? And how did you track it
Yes.
down? How did you track it down? I mean, why that division by zero was happening? How
Sir,
did you debug
because
the code?
what we had was in the error, we had the centroid of the x value, which basically we was dividing it by the moments, which basically were getting zero when we were subtracting it. So like for that, we changed the like the height and the width value. So if the we are basically getting the error on the base of the height and the width got from the camera. So like
Mhm.
then we divided the height and the width by some numeric value, and then it worked.
So, but the new code that you have written, is it not going to hit the division by zero problem if I give you a different track? Maybe a track with different features?
Mm,
I mean, how did you
no, sir.
avoid the division by zero problem? I mean, can you say that there are no division by zero problems in your code anymore?
No, sir. Like for now, there are no.
But if I change the track, it might come up. I mean, the centroid
Sir,
might.
like we had a randomized track. So on like there are two tracks. In the first one, like there was something like U structure first, and track the first part of the track was like a hard turns one. So like in both the cases, our robustness was also there. We also
But
tried like differently, like for a line following, we just switched the mode to the line following, and we were saying that whether the line following alone is working or not, or the wall following is working or not alone. So
yeah,
like
so
that also we tried.
this is very good, but I think you should also maybe think about, discuss amongst yourselves when you have some free time. Because suppose you wanted to deploy such a robot in an unknown environment, you wouldn't know what's going to happen, and you don't want this floating point. I mean, there have been catastrophic failures because such corner cases were not taken into account. I mean, multi-billion-dollar projects have, come to knots in a second. So, to avoid these errors, that there are no division by zero problems ever. I mean, you can easily detect this, right? You can figure out the whatever number you're dividing by, whether it has become too small. And if it has become too small, then all kinds of numerical problems are going to show up. But it's very impressive. I mean, all of you are from 8th standard, right? Or there's some 9th standard.
No, sir. There is one boy who is from ninth grade. The other three, we are in eighth.
Okay, it's truly impressive. Thank you. Keep up
Thank
the
you.
good work. Yeah.
Thank you.
So,
In fact,
thank
I might add here that adults also make mistakes which manifest in very strange ways. There was this case of an American fighter aircraft which was being flown to Australia from the US. I think that's an example which is widely given, no, Supratik, where
There are,
this,
I mean, that list keeps growing, Kavi. I
yeah,
mean,
because when it was flying, randomly it would just flip upside down and keep flying towards Australia. And they could not understand why it's doing that. And finally, they realized it's a bug, which is not different from your floating point that divide by zero error,
correct.
where they've been testing the aircraft in the northern hemisphere. When it crosses the equator and goes into the southern hemisphere, there is a sign interchange, right, from plus to minus, with the result that in order to keep the flight dynamics equations stable, it would flip the aircraft upside down to respect that. Okay, so these problems do happen in real life. In fact, Professor Supratik's mission and his job in life is to build tools that prevent these kind of mistakes from happening. Formal tools and tools which help you reason about uh, software and systems and hardware also. Supratik, if you can just kind of tell them a little bit about what you do and then give a summing up,
Oh,
and
okay.
after you, Ajit can also give his few words and we'll close the session.
Yeah, so I mean, what I do basically involves that, I mean, there are things where safety is of very high, importance. For example, uh, actually, every time you have traveled in a high speed train, even in India, or you have flown in an aircraft, there is a lot of software actually running which is controlling the train's motion, the airplane's motion, and a bug there can be completely catastrophic. It will just lead to accidents, loss of human lives, loss of infrastructure. And so, when you have such safety critical things where the cost of a bug is very, very high, you are never sure. I mean, no matter how many test cases you run, no matter how many random test cases you run, you're never sure that you have covered that last corner where which can show up in real life, and which can and where a mistake can sort of be very, very costly. It can cost human lives. And so what I work on is ways to ensure that the software that controls the safety critical missions, airplanes, even cars these days. Cars have a ton of computing and processing involved in them, uh, and of course, things like space missions and all of that, nuclear power reactors. A small bug there can just be catastrophic. So I basically work on ways to make sure that there are absolutely no bugs over there, so that we can sleep well, knowing that the computers are really doing their job right. Thank you, Kavi.
Thanks. And perhaps I'll let Ajit wind up the panel by summarizing our impressions.
So I have a very quick question for for the last team. Did you ever encounter an infinite loop? You know what is an infinite loop?
Yes, sir.
So can you tell me what it is? Have you ever encountered this
So,
problem in this project?
yes, sir. So, sir, there was one time when I faced that the loop was only like going like it should have not be going infinite only. Like it was
Okay.
running and running only.
Yes.
So
Yes.
at one point I needed it to stop. So in the final task only, if I say after collecting all the waypoints, it was still actuating and was like going out of the world only. So
Okay.
like this type of problem I face.
Okay. All right. So, okay, that's the only question I have. So to summarize, I've really had a very nice 2 hours here with us, brilliant demos from all the teams. I'm very happy to see this. Such a young age, I would never have dreamt of, being able to do something like this when I was in 8th standard. In fact, I remember when I learned computer programming much later in my first year engineering, and I struggled with C programming at that time. And infinite loops was one of the biggest things that I faced, so that's why I asked you this question. So it's very nice to see you children doing this at a very young age. It's very good. Keep it up. Uh, it's also very nice to see, since I'm from the image processing area, that image processing is being brought to school students. This is a very nice thing that is happening. Uh, and that you're learning to program not only in Python, but also learn packages like OpenCV, right? I will just give a general tip to all the participants that when you're trying out all these tricks, you're trying out different thresholds, etc. Some of it can be a little ad hoc. You should always question yourself about the robustness of these assumptions. When you change lighting, particularly lighting change is a big challenge in image processing and computer vision. So just think about it. I'm not saying you can arrive at a perfect solution, but just be aware. Okay. Another thing I will tell all the participants, try to find out a little bit about color spaces, particularly hue saturation value. They are very interesting concepts over there, and try to just push a little further. Okay, you've already done very well. You can still do these additional things. It will enrich your knowledge. Okay, but on the whole, I'm very impressed by the competition, by the programming that effort that you've put in, and the conceptual effort also. Okay? So wish everyone lots of good luck. Okay, and congratulations to eYantra folks also for organizing this endeavor.
Thank you, Ajit and Supratik and Romesh for spending your time. Romesh, I hope you'll stay on a bit. But there's an ulterior motive, as always, right? I'm hoping that Ajit will help us put together a little MOOC on image processing for the next competition where we will have real robots and all these problems that he's speaking about lighting conditions and all that. And I hope Professor Supratik would work with us in developing a module on how to write robust and reliable code. That will be very exciting because these are things that kids don't think about enough, right? About how to anticipate problems before they can happen. And this is a good attitude in life anyway, but translate that into the programming domain and you become a very astute developer. Thank you very much. I'd like to thank and a big hand to our faculty for having invested their time with us, more time than they had scheduled for. We had asked them for 1 hour, but they spent 2 hours. We are touched and we are privileged. Thank you very much. A big hand to our panel here. Thank you very much, guys. So I'll hand the floor back
I think
over to
Ramesh wanted
Deepa.
to say something, Kavi. I think
Yeah,
Ramesh
Romesh, you want to say something?
No, I think you said it in a different way, but I, as a person from industry, would say, I think while eYantra is doing a fabulous job, and I think to start 11th grade and 8th graders to think about these lines. And as Professor from IIT said, that Professor Supratik said that you normally learn it in the first year. That said, I think it's very important to inculcate the culture of doing a lot of what if in terms. I think if we could also train kids in terms of that what if, which means basically risks, what can go wrong, whether it is infinite loops, whether it is the zero denominator, or whatever. I think a little emphasis on that, so that, because I say this because while the Indian software industry is kind of presented in a big way around the globe, but I think we discover a bug overnight, large teams are at work, we don't worry about and back. So I think if people are trained to learn, doing it the right way and using the right tools in term, after having done it, using the right risk assessment or what can go wrong kind of tools, it would be a tremendous advantage, which will kind of be a cultural or a temperament kind of a building exercise. Thank you very much for that. Sorry, I didn't want to take too much time.
Romesh, point taken. And I think Supratik and Ajit both deeply believe in that. And I think what is needed is a cultural change. And I feel that we've taken the first steps in creating this, as you said, what if attitude, a curiosity, a desire to actually build things with your hands from when you're in school rather than learn everything in a book. So make your engagement with life more experiential, and also make your engagement with life more as a problem solver, because that's, I think, inbuilt in us, and we need to sort of blossom that inclination in young people rather than turn them into, you learn by rote and you pass exams, because that's not, life is not an exam, right? It's much more than that. So thank you very much for having been with us. I'd like to hand the floor to Deepa now. We have a panelist on the next panel. I think Alka has to leave at 12:30, so we'll respect that. But we have Professor Paritosh Pandya here with us, who is a researcher in a similar area to Professor Supratik's, which is safety critical systems, reliable systems, model-based design, how to design your system as a model and generate all the software and all these kind of things that you need. And we have Romesh also with us on the next panel, I hope. And we'd like to just move into that. And we have Alka Hingorani, who's from the Industrial Design Centers. She comes from a different perspective. She comes from an art history background. She said, what role will I have to play in your robotics panel? I said, you play the humanities and sociology and design card, right? Because there's a large element of design in what the students have been doing, and pegging all that in a societal context, and to see how we can drive this thing in that kind of context. She's been working on a very fascinating project funded by the Tata Group, where they are taking village students, inviting them to tell their stories, illustrating their stories, and then using a professional team to convert these ideas and these stories into a professionally world-class bound book, storybook, with amazing printing. And they use designers and artists to improve on the look and feel of the thing. It's a very interesting project. So I thought maybe she can bring those same sentiments to eYantra, and I have no idea what will come out of it, but let her just experience this and see what we can do. So over to the next panel here, Professor Pandya, who's teaching a course with me, incidentally, on embedded systems at the moment, and Alka, and we have Romesh also here. So over to them and the next panel.
So Kavi, how do we submit our scores? We should just enter in the spreadsheet?
Leave it. Yeah, you just fill that, leave it, and we'll get it.
Okay, so I was thinking that since the next team coming up is KV IIT, maybe I'll just stay there as an observant.
Please do. Okay. Please do. We'd love you to do that.
Yeah, so I won't comment, I'll just observe.
Please comment also.
Yeah.
Okay. Deepa, Rishi?
Yes, sir. Thank you so much, sir, for explaining. And Rishi, I just have few words here. Like panel 1 was really enriching and it was really insightful. Thank you for the knowledge transfer that has happened among the judges and the students. And we request all the students who are there in panel 2 to be alert, to be active, so that all the members are there. And we hope to have a again energetic panel 2 session with our judges and team. So Rishi, you can start now.
Yes, the Kendriya Vidyalaya KV at IITB is up next. The team consists of Shivna, Anjaneya, Maitri, and Advait. I'll play their video now. Keep in mind that the video has some source audio problems, so yeah, just bear that in mind. Yeah.
Hello, we are Team 5 Shocked Circuits. We will be talking about our experiences from this competition.
When we entered this competition, we had very basic knowledge of coding, and we were actually worried about how we would fare in this journey. But the instructors taught us really well, and we actually learned everything we're supposed to learn.
They taught us from basics like hello world, write and hello world, and then it went to line following and wall following. So I'm very glad that the instructors and others around us took extra time to explain right from the beginning.
Some of the challenges that we faced were that since the age group of this competition was 8th to 12th, there were few topics that were beyond our knowledge. An example was in first task when we were told to solve an equation in circle tracing. We had many failed attempts to solve it, and in the end, we had to ask our friends and family.
We never really faced any problems due to COVID-19 as we were accustomed to, the online school and working online. I may say that it sort of helped us because we could meet at any time, anywhere, and very frequently. I could just tell them, oh, should we meet? And within 2 minutes, we'd be in the Discord voice chat. Uh, we were very bored while the whole COVID-19 lockdown and the pandemic. And it was really interesting and fun way to spend like towards the end of the lockdown here doing this eYantra.
eYantra was bound to be different from other competitions. As well, this was our first competition that was to be held completely online. So I felt it was a very unique and wonderful experience. Thank you.
End recording.
Yeah.
Hello, this is Shivna K from Kendriya Vidyalaya IIT Bhavan, class 9. We are from Team 5 Shock Circuits. Now I'll let my team members introduce themselves.
Hello, I'm MC Maitri from 9.
Hello, I'm Advait from class 9.
Hello, I'm Anjanya from class 9. And we are Team 5 Shock Circuits. Now, let's have a look at our output video.
Hello, we are Team 5 Shocked. Welcome to our final task output video.
Before we start the simulation, let's have a look at the code. All 210 lines of the code have been commented and explained. Now, let's start the simulation. Simulation has started. Metrics tab is open. Our algorithm works on the basis of a variable known as robot state, which is set by default to wall follow. Once the robot detects red, this robot state changes to line follow, using line and then uses the line following algorithm that we used in task 5, while our wall following algorithm is based on our task 3 wall following.
We have reached 25 waypoints. We have reached 50 waypoints.
ePath detects red and therefore wall following switches to line following. We have completed 75 waypoints.
We have used two proportional controllers. A value of B is 0.75 times max speed. Our KP value for wall following is 0.5 and our KP value for line following is 0.
In line following, we have resized the frame of the image to 500 by 500 and line following for convenience in calculation.
We can see that our robot is able to take 90-degree turns with relative ease.
We are approaching the finish line.
We can see it has reached all 135 waypoints and the task is completed. The zip file has been successfully saved. Team ID 5, short circuits, signing out.
So yes, that was short circuits from KVIITB. If you're here,
That's a
guys,
short,
just
short video from short circuits.
Yeah.
Yes.
So since
So maybe Alka, I'll let you lead.
Thank you, Kavi. Thank you also for a very kind introduction. It has been very interesting to see the earlier session and the questions that people were asked that were much more directly connected to the task at hand. Mine are going to be broader. I wanted to see if one or more than one of you could talk about one of the challenges that you faced um, that was difficult, but you were able to overcome it and explain to us the path that you took to meet that challenge. Can you pick any one point that you thought was particularly arduous?
Okay,
And
so
how you met that challenge?
may I go? Can I? So
Please.
basically, in task 4, we had to use image processing to detect colors and shapes and move according to the color and shape that we saw. Right. So in one of those, we took so the process that we used to write the code was we took code from the ND book and used it in our own way to complete the task. So, but the code in the MD book that we used, that we based our code on, that code somehow had some issues, and we those issues crept into our code. We didn't copy, of course, their code, but we based it on their code, and that sort of affected us. Basically, the problem was while detecting color, we had to threshold the image, and this thresholding and while detecting the shape, and this thresholding became rather extreme, basically, and this went undetected until we actually had to do it. And at this point we were just very confused because everything came to, regardless of what the actual shape was, the shape would come as a rectangle, which it obviously was not. And so then in the end, I jokingly said to my friend, you know what, I'm just going to take this, I'm going to throw it in MS Paint and look at the actual threshold dim. And I saw that, and the thresholding had turned everything black instead of keeping a contrast between the black and white. And so we toned down the thresholding to a much less aggressive sort of thresholding, and then it actually saw the contrast between the black and the white, and then we detected the shade. The joking comment about I'll just put in MS Paint and see what's wrong with it actually seemed to help us. So that
Right.
was an example.
Nice. So changing your the place where you were looking at it became the epiphanic moment. Okay. Okay. Have you guys thought about, as you were working on this exercise, it's 10 weeks, I'm told, that all of you have been involved or engaged in it. Clearly, you were also learning many new things. So much of this was not something you already knew how to work with. But did you get any chance to think about any larger application of what you are learning?
I think we had learnt a lot of Python from where we started. So I think a few of us were like, how about we try to expand our knowledge?
let's try to create an app. I think someone on a Piazza post said we should be introduced to Flutter, which is a app building thing. So we are currently trying to work on that now. As we finish this project, we're going to move on to another.
Okay, thank you. I'm good. If someone else has a question, please.
So what is the change now that you mentioned that? So what is the change? What is the difference between you before the competition and you after this competition, Advait?
So I think I came into this competition with like very little knowledge of Python or like any basic coding language. So I think it was great that the eYantra team actually line following and wall following, so much so that we actually understood everything and were able to like keep track.
If I may add to that, I also learned how I had fun while tinkering with the values. I learned that just not just putting the value, but also checking and keep modifying the values were more fun for me than to write the code, because you just keep playing with it and suddenly there's a eureka moment. So that was very fun for me.
Yeah, so actually, when we entered, as in when we started into this program, at least for me, I didn't know coding at all. But now, at least, I know what line following is, what wall following is, how the basics of coding, and also a lot of teamwork, which is quite good.
Okay, this is interesting. So before I give the floor to Professor Pandya here to ask a question, we were very concerned. I was very concerned and felt responsible that are we distracting you guys too much from your real work, which is school work and stuff like that? Are we despairing your parents by parents want you to just काम करो, competition में मत time waste करो वगैरह, right? That's how parents usually look at these things. So what has your experience been of that? I mean, have we distracted you from schoolwork? What has the effect been of our intervention? I might like to ask you because it's overlapped with your exams and all that, right?
If I may answer, basically in school, as I said in the video, we were getting very bored. Our school was taking classes, obviously, but I mean, there was a lot more free time here, and this competition definitely came in and helped us utilize our time and get away from watching Netflix or YouTube or whatever it may be. And I don't think it really affected our schoolwork and our classwork. I think it was in addition to that. I may say, like one person said about how you start reading the textbook as a manual. It in certain places even enhanced our schooling, knowing this and doing this competition. I feel definitely, and my parents were very supportive of me. So yeah.
Yeah.
That's very reassuring to hear. Anybody else would like to add to that
So,
about parents?
Kavi, associated question. You talked
Yeah.
about stress on the participants. How about stress on your
Sure,
parents?
go on,
How much were they invested in your project, and how much interaction did you have with them? This has to be asked because you are IIT kids.
My
Yeah, so
Yeah, sorry, I'll.
no, go ahead, go ahead.
Yeah, so my father didn't really pay too much attention to it as I was basically figuring out stuff with the other guys here. We basically were independent, more of, I would say. I don't know about others, but I never really had to ask my parents or my sibling what to do here or what have I done wrong. There
But
were
did they
few
look at it at
instances.
least, what you were doing?
Yeah, my brother
Great.
actually took some interest. He was asking, "Oh, how's this going? Okay, maybe you should try this."
Wow.
Something like that.
Okay. Anjaneya?
my parents were very interested and very happy that I was doing this, but not very invested. I would say they were like, good, you're doing this. They didn't, they thought I'd be able to manage, and they didn't think that I'd fail or there'd be anything to console me about. So they really were just taking a passing by interest.
Yeah, actually, because now since it's quarantine, we've got quite a lot of free time as well.
So yeah.
Okay, so one more thing I'd like to ask, apart from the technical question and all that, right? Has this collaboration mode taken you to a space that you had never explored before, or are you used to working like that? What is it new that you learned in this collaborative mode?
I think it was basically like us sharing experiences on like voice calls, talking about how we've done such things or whatever. Basically, I think it was a good experience for us to like build our teamwork with other people or anything like that.
So, would you say that a team is the sum of the parts, or sum of the parts multiplied by a factor?
It's much greater than the sum of the parts. Individually, if you just look at our skill level, we were, when we came into this competition, even where we're ending this competition, we couldn't have done it without each other. Any one of us or all of us doing it independently also wouldn't have worked. It was because we had sounding boards, we had to each other, to talk to each other, to collaborate with. That's how we reached where we are, and that's how we managed to do this, being in ninth standard with all of us together.
Excellent. You heard of the term Ubuntu?
Yes.
Yes. Together we win. Together
Yeah.
we solve problems. I think that spirit is needed more and more. I don't think it's taught in schools. It's actually learnt on the sports fields. But nowadays, with not too many people playing sports, maybe we need to turn to the same machine on which you see Netflix to learn collaboration. So I think this is something which the anthropologists should take away from this work. So Alka, a little kind of being there for you.
Yes, certainly. And I'm enjoying very much how articulate all of you young people are about the ways in which the process has worked for you. It's enlightening.
Okay, thanks. So this is quite some learning. So Paritosh, a question from you before we move on, or
Yeah, I
Rumesh?
think at least one technical question, if you like.
Yes, yes.
Yeah. So, I think you went through quite a journey, learning quite a few concepts during this. Some of you mentioned one difficulty point that you had detecting, calibrating the hue thresholds, right? Now,
Yeah.
did you learn about what these hues are? You've got this color space HSV. There are three components to it. So, what is the kind of introduction you got to the what these three values mean, and which one is more useful for you?
So in our thresholding, we were thresholding a grayscale image. So yeah, but
Okay.
the instructors did introduce us to HSV through the MD book, and there was a whole one page about the HSV. Yeah.
So if you're just thresholding on the grayscale, you see your transition from following using proximity, which was on green background, to line following happens with a red patch, right?
Yeah, yeah, yeah.
Do you think hues would be useful in making that more robust?
I'm guessing they would be.
Yes. So did you think of these alternatives? You see here the thing is, I really like what your guys are doing. You're learning with real experience, and experiential learning goes much farther than just learning rote from the books. So you can also experiment with alternative design strategies, right? About so did you have any difficulty in detecting the transition from?
Well, in the initial task for in the image processing, we had learned how to detect red. So we
Okay.
did have a few issues about the contrasting black line on red, but we
Mhm.
did in the end solve them by saying if the background is red, then we have different values of thresholding.
Okay.
If the background is white,
Excellent.
so like that.
Excellent. So, just one associated question. These issues are very real. And, unfortunately, all the threshold values that you got will change with lighting conditions. You know,
Yes,
I know
definitely.
several eYantra projects which work in the morning and stop working in the afternoon because the lighting is different, or you change the room. So maybe one food for thought is how to harden the design, because robustness is one of the issue, is to make it more adaptable to lighting, maybe some calibration, you
Maybe
know
the thresholding value be a variable instead of a constant, and
Right, and then you detect it from the ambience,
yeah, from the ambient light you change that variable
or
for
the image. You've got the whole image to detect the ambience. Okay. The second thing I wanted to ask you was, when you detected the centroid of the line, or you detected the distance from the left wall, what strategy did you use to keep your distance? After all, you have to turn the robot in the right place, right?
Oh, sorry, could you repeat that? I didn't
Yeah.
understand.
So when the robot is moving, say in the first phase, you detect the distance from the left sensor, right? How close you are to the wall,
Correct, yeah.
and based on that, you move the robot near or far, right, to the wall. How do you
Yes.
decide the amount of corrective action?
The corrective action, we're using a proportional controller
Hmm.
and we're using a KP here. So the greater the thing, like the greater the magnitude of the distance, the more it reacts.
Yeah.
So
So,
it's basically like
so
more
good. I
even
got it.
than,
I got it. I got it. How did you decide the value of KP?
so
I think, yeah, sorry.
experimentally basically. So we
It is
looked,
basically you tuned it, right?
yeah, we tuned it. We kept on running simulations and saw how well it was, how fast it was going, because we didn't want it to be perfect and just very slow,
Right.
or we didn't want it to go fast and just start crashing into walls, right? Because
Right.
it's not reacting with enough aggressiveness to the error, so it's
So,
just going fast and crashing.
so Anjana, I very much like your words. You say that the speed at which you are moving also affects how much you correct by, right? Huh?
Yeah.
Do you think there is some requirement of also including velocity into this calculation, or talk about what was the past distance,
Experimentally
so have some memory?
by just by yeah, sorry, continue, sorry.
Yeah. So did you study any literature on this, how this amount of correction is decided?
I don't think we've looked at it, but experimentally, I have made a few observations. Is that the faster it's going, the faster the robot's velocity is, the more the KP needs to be, the more
Right.
you need to aggressively react. This is just
Absolutely.
experimentally, so it may not be exactly
Great.
that.
So
And if
here
it's
is your chance to learn something called PID controllers, proportional integral derivative. There are three kinds of constants that you may want to use, and those give very good performance. Uh, See, one symptom of what is going on is that when you are making the turns, you are undershooting the line. You are going slightly, if the turn was right, you are on the left of the turn. you know Sometimes if you use some other kinds of compensation, you go to the right of the line, you will overshoot. And not only do you have to follow the line, but you have to control the amount of overshoots and undershoots, and there's the whole theory there. So there's a world for you to study. But I'm very glad you got this experience of seeing this. I think this is the two questions I had, Kavi.
No, in fact, it's a extremely good point, and this whole notion about choosing KP. I just wondered if Anjanaya and your team, you kind of did this just by testing various times, or did you make a table and plot a chart to see how
Yes.
the behavior actually changes according to how you change a parameter?
Up
so we
to
didn't
some
actually
level,
plot
we
a
did
chart,
that. Yeah, exactly. We didn't plot a chart, but we
but
were basically seeing which value is too, it's like overshooting it or undershooting it.
I
And
mean,
then
by
going,
the time we came to the final task, we had some notions of, oh, this value, this will not work. It will just be perfect, but it will be so slow that it's impossible to work with. Or that this value, it will not, it won't be accurate. So we knew where the value we wanted lied, which range it lies in. Through, I mean, so we had some notion of the values. I mean, I'd written it down in a text file somewhere that the value ranges between this and this for whatever we need to do, ranges between these two extremities.
That's a very good start. In fact, did our team ask you to maintain a diary of the entire project from start to finish?
Uh, I don't think they
The
did,
eYantra
but
team asked you to maintain a project diary from start to finish. I just wondered, did you have a project diary?
I mean, our
mm,
Discord channels basically may function as
yeah,
diaries
We
because
can
we've
just
sent
scroll up
messages.
and down and
So
see
I
what we did.
so I've also
Okay,
gone
okay,
up
okay.
into my Discord chat channel and I've seen, oh, this is how we did this particular thing, and that was our logic behind doing it. So in that sense, it functioned sort of as a diary. Yeah.
So would you, if you did a project which is a little bit more complex like this in future, perceive the need to maintain notes on a daily basis so you can go back and see why you made certain decisions and things like that, and maybe even do some chart plotting to have a better idea of how certain parameters change the behavior?
Yes, definitely.
Yes.
We were very unorganized here.
Can I
At times, we would just not be able to find what a certain equation is or anything that we've done in the past.
can I
Uh,
butt
That's
in,
probably the
Kavi,
meta
for building on your
documentation that
Yes,
some
yes. But the nice thing is, Alka,
we
they have perceived the need for it. And that's a great starting point, that
yes,
experientially they have
absolutely.
discovered for it. I think
Absolutely.
Romesh is trying to ask
Romesh
a
is trying
question.
to say something, yes,
Yeah.
but yeah.
need for that in perspective. I think first of all,
We can't hear you. Bring the mic closer to you.
are you able to hear me now?
Little bit better.
Yeah, better now. Is it?
Yes.
Okay. Now, first of all, I think in the engineering terms, it is called an evidence binder. So, which is a, Kavi, your favorite phrase. Some of these kids will go on and want to knock the doors of venture capitalists and so on with their developments one day. So, when you do that, you need to have your evidence binder with you, either on a laptop or on a hard copy or whatever. So all the tinkering that Maitri did and all the charts that you said that they created or should have created, I hope they have created those charts of either tables or charts or whatever. All this kind of information goes into an evidence binder. So if a question comes, but what happened if you had changed this KP from this to this? What would have happened? So I think tuck comes the answer. That this is what would have happened. Everything else remaining same. If I change this variable, this is what I would have happened. So in engineering terms, in product development, at least in the auto industry, we used to call it an evidence binder, which is like it's a binder or a catalog or a diary or whatever you choose to call it of information of your journey, of your what you call story from day one to day end. And this comes in very handy when you go on to future projects. And I'm a big believer in documentation. I think the one thing that kids need to develop, and one thing that I need, which I see some of the younger kids kind of do not pay enough attention to, and I think it comes from our culture because we come from a culture where the guru shishya parampara, and you work in the old, your guru's home, and you don't have a notebook, you have nothing, you learn everything from washing utensils, which comes in handy during the COVID time, to actually dhanush vidya, to everything is, or music or carpet weaving is all on sing songs. Nothing is documented. So I think it's one of the reasons why we are not first time right in our attempts. Now, the moment you build, and I'm not going into artificial intelligence and so on and so forth, the moment you build this document binder or evidence binder, you also willy-nilly move into the artificial intelligence area. Because then your system or wherever you store it or wherever those experiences are shared will actually help you predict and tell you what you should do and what you shouldn't do. Kavi, I hope I'm making sense.
You're making a lot of sense. In fact, I'd like to say that if people apply for patents, often one of the evidence that they have to present along with the patent is their engineering diaries, which shows the ownership of the idea by showing the development of the idea and the documentation of the idea as it's growing. That's one thing. And I'd like to say that the Indians have been overpowered by conquerors in the past, especially East India Company, because these people were able to control us because they used to maintain extensive documentation and they had very effective management techniques through documentation of transporting knowledge from here back to the headquarters in London, where decisions would be made. And all this comes from this
Unfortunately,
tradition of bookkeeping
they
and
thought as well.
documenting what you're doing.
There was one information for their information for presentation to the world. So, which is not what
Yes.
which is what we should do.
So
But
I
anyway,
think
I have two simple questions, Kavi, if you may allow me that luxury.
yeah, sure.
what is the first of all, what is the range of standards or grades that the participants of this team, what is it called, shared
Shock,
sorry
shock
shock
circuits.
circuits. So what
We
is
are
the
all in
range
ninth,
of
sir. We're all in
nine?
ninth, sir. Yeah.
Great.
Wow.
Hats off to you. I don't wear a hat. I have a pigtail. Hats off to you guys. I think great stuff. And as
Wow.
Alka said, most of you are so articulate, although some of you have not spoken as much. But very, very articulate, very, very impressed. In eighth grade, I couldn't even solve a maths problem, writing code and figuring out problems in a code. Lastly, unfair below the belt. What kind of an unfair advantage literally, COVID notwithstanding, you are at a stone's throw from eYantra headquarters, so to say, the mecca of eYantra. What unfair or fair advantage did you have because of that?
I hope it's
Go
not
ahead
an
Romesh,
and
unfair
share.
question.
No,
nahi, nahi, Romesh, I'd like to take that if you don't mind. They've
No,
had
no, no, no,
no.
no, 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 no. That will be between you and me on the side, Kavi. I want the kids to respond, please.
Okay, fine. Let them answer the question.
Anjanaya raised his hand, so he
all
should respond.
I'll say in our defense, the only place where we told anybody that we were from KVIIT Powai was only in one field where they asked us in the beginning of the competition your home address. Apart from that, we have never publicized the fact that we have any. I mean, the only unfair advantage we may have received is Shivna getting to know about this competition because she's in. Apart from that, I don't think we have got any other unfair advantages.
Yeah, because
No,
every
no. When I say unfair, I mean easy accessibility because you are physically there. That's why I qualified by saying COVID being in place. Did you get any benefit or does proximity help? I may have not worded this question so well.
Proximity. I mean, I don't think proximity really helped because the mode of this competition was fully online, and so we didn't ever, meet the people on the street or anything. We didn't interact with them physically. We
No,
are in.
absolutely.
Sorry to have been rude, Kavi. You may respond. I mean, I leave it to you.
Yeah,
My question.
I'll tell you, even I don't know anything. It is a team which manages everything, and everything is managed objectively through a process which is totally transparent and which gives nobody any advantage. And this competition is all online anyway, and we just go with the numbers that we experience, right, from the students corresponding with us through Piazza and through the various. So everybody appears to us exactly on the same level. In fact, I was a bit nervous. I must say, I do admit I was a bit nervous at perhaps the KV team not making it to the finals, but I kept it to myself. I thought it would be a real pity, right, that if someone on the doorstep doesn't get to the finals. But much to their credit, on their own merit, they made it to the finals. So I must kind of appreciate that on their behalf. And apart from all that, Romesh, look at the quality of the interaction, and I don't have to say anything more. My case rests.
I know, Kavi.
I'm
Don't.
I'm going to say I'm going to say one last thing. I have to leave. I'm already late for my next meeting.
Certainly.
I think Ramesh's question is far larger than
Yes.
the question of whether these people had access to the eYantra team or labs any more than any other team. Privilege is normalized within campus, and imagination and possibility is increased just by virtue of being around people who have achieved what they have achieved and live on IIT campus or study in any part of it. That is not the responsibility of these young people. But because all of you seem more sensitive than even your years, you must remember to also acknowledge normalized privilege. Just the fact that you are on IIT campus puts you in a bubble that the top 1% of the world occupies. There is no way to escape it or deny it. But having said that, the fact that you guys have worked on this together, all kudos to you. I'm really sorry that I cannot stay any longer for this meet, Kavi.
Sure.
But perhaps there will be other opportunities.
No, thank you. We
Yes,
did
Thanks for
I have to.
that support.
did
Otherwise,
appreciate your
Kavi would have killed
interactions.
me offline.
Thank you. Bye bye.
Yeah, we have Romesh to back you up here.
Yes, thank you.
Okay. Thank you.
Bye bye.
Thank you for being with us. Take care. Yeah, Paritosh, an observation that you'd like to make, I'm sure.
Well, I mean, this is truly, I mean, at ninth standard, I can't imagine mastering so many different problems, and that's the nature of the problem. They don't come cleanly into physics paper and chemistry paper and programming paper. I mean, everything has to be put together to solve the whole question. And this experience that you have had, I can't imagine. It was not there in our past. So I think, and I'm very impressed with what you have achieved. Also, I'm very impressed with how articulate you are about your experiences and your strategies and what you went through. So certainly my congratulations to the team. uh, my one comment is that whenever you face any of this practical difficulty, there is a body of knowledge out there. You don't have to really try out everything yourself and discover it by yourself. There is just isn't enough time in life to do that. So maybe it's a time to be a little curious about, okay, what could be the principles which govern the kind of issues we have faced, and to look it up a little bit on Wikipedia or something. So, for example, in this color spaces, there is a rich world to explore. In terms of closed loop control, there is all this, as I said, proportionality. How do you decide constants? Kavi said you should do some calibrations, there, or you could use a proportional term or a derivative term. I mean, and not just position, maybe you bring in velocity, right? So I think this will I hope motivate you all to go deeper into the subject. This is just start of your curiosity about the world, and there's a lot of knowledge out there. That's what I would like
Thank
to
you,
say.
Paritosh. Good work, guys. I nice to see and really appreciate it. And maybe I should hand the floor back here to Rishi. Rishi, we are a bit short on time, so we'll have to accelerate the next few teams because we've spent a bit of time here. So over to you, Rishi.
Yes, so the next team coming up is MAAC programmers from St. Mary's High School in Mumbai. The team consists of Abhishek, Movin, Ammar, and Christopher. I'll play the video right here.
Hello everyone, I am Abhishek from Team ID 61 and my team MASC Programmers. I am in 8th standard. My school name is St. Mary's High School.
Oh my
My
god.
hobbies are playing badminton and doing coding and playing many more outdoor games. Thank you.
Hello everyone, my name is Movin D'Souza. My team ID is 61 and my team name is MAAC Programmers. My school name is St. Mary's High School SSE and my hobbies are playing cricket, reading books and editing videos. Thank you.
Hello everyone. My name is Christopher Coutinho. My team ID is 61. My team name is MAAC Programmers. I am from St. Mary's High School. My hobbies are playing football, playing badminton and other outdoor games. Thank you.
Hello everyone, my name is Ammar. My age is 13 years old. Read books and swimming. My ambition is to become a pilot. Thank you.
Hello everyone, this is Abhishek from Team ID 61 and the team name is MASC Programmers. So let's start our demonstration video. So first we have made a function of wall follow and then we have implemented in a while loop. That's why the robot is moving perfectly in wall follow.
Thank you for watching our demonstration video of our task. I hope you enjoyed this video.
Um, yes, thank you, MASC programmers. Both of us, me and Arjun were here in the control station. We liked the video a lot, and I hope all of the audience liked it as well. So if you're here, can you just unmute yourself in that video so that we can see you?
Okay.
We request the team to be like unmute the mic and turn on the video. Yes, sir. Like you can ask the questions, sir. Like,
Okay. Kavi, or shall I start? Deepa, I think there are some audio issues.
yeah, we can hear you, sir. Like, Abhishek, Movin.
Okay. I'm having difficulty getting your audio. Okay, let me ask my question. So, how much had you had any experience with Python programming before?
I have some experience with Python, but robotics was an entirely new subject. Like
Mm-hmm.
I knew Python before, but robotics was an entirely new subject. I didn't know anything about robotics. So this was the first time I was doing robotics, that is virtually.
Right. What were some of the challenging things that you met during the course of the project, and how did you solve some of those difficulties? Can you give us your account of those?
So the most challenging thing was understanding the physics and math concepts.
Okay, so can you name some of
Yes,
the
sir.
concepts which were interesting and took some time to understand?
Like the task one, when we were not familiar with robotics, the
Mm-hmm.
future chapters, it was very difficult for us to understand what they were telling and all the formulas. So we took help from eYantra team and also from some of our school ed students to explain us the physics and math concepts.
Okay, okay. But now you look forward to studying that in your coming years. You can see it working. Right. In terms of executing the project, where did you have the most difficulty? This was about the
So the
learning part.
difficulty was that finding the red color and switching to one controller to the another means wall follow to line follow.
So how did you handle that?
So we gave a variable name bot mode, and then we gave an if else statement in the while loop that if the color is red, then bot mode is equal to line follow. And then we have given an elif statement which says elif bot mode is equal to line follow. So if there is no red color, with the controller will switch to line follow.
So I have some associated questions here. Firstly, how do you know how red is the color now?
We have defined the lower red and upper red on the HSV scale.
Okay. And from the
We
HSV
also
three
give
values, how
thresholding
did you
values for
choose?
the red color.
So you have three values in HSV, right? The hue,
Yes.
the saturation, and the value. Which of this is more useful in detecting whether you are in red or in green or in black?
For detecting, we use lower red and upper red values.
Yeah, but that's one value. You have three values here in HSV.
So see, we have defined lower red and upper red. Lower red
What
we
is
have
lower red?
Yes, we have given some values on the scale of HSV, and upper red also we have given some values on the scale of HSV.
I understand that. I'm trying to
Yes.
say how you decided those values.
That part Movin will explain.
So most of this kind of like complicated course it was given in MD book. They were studying about that and the lower we were talking about that and the lower red means the darkish part and upper red means the brightest part of the red and which contains three different values according to
Okay,
BGR means blue, green, red format.
right. Uh, how did you decide the velocity at which the robot will move?
So,
We
so we tinkered with the values, and then
And
when we found a value that was correct, we decided to keep that value as our main code.
no, but what were the trade-offs? If you move too fast, what would happen? If you move too slow, what would happen?
Like
If
in velocity visible, we were keeping it an average value and different the turn reaction. We were experimenting we were experimenting QP like once the QP is increased, what happens, and if decreased, what happens. So different values give different results.
Hmm. I mean, how did this different? Suppose you moved the robot at the maximum speed, what would go wrong, or could you give us some feedback on your experience?
Then we tried doing it into maximum speed. Then the most commonly error printed was that the speed exceeded. Like we were adding also values to code. We
Oh,
were adding also values by one follow. That's why.
so it would exceed the range of allowed values of speed, is it?
That's why we were keeping half of it.
Mm-hmm. Okay, yeah. Okay, so I think from the tech, any other part that was kind of tricky for you to handle, and you had one was this hue detection at the switching of the mode.
Is
Other was
also
this
the difficult thing was that line following. So our thresholding value was not coming proper. So we tried, and at last we got a perfect thresholding value. So the robot can do line following properly.
this is threshold for what, between black and white, or
So like the thresholding value has we came to know that slowly we were taking images from the camera that when it's
Mhm.
red, the line which is in the red area, the thresholding value has to be increased, the black part has to be increased, and when the background is white, then it has to be decreased. So the thresholding value was never perfect. So we instead of making one line follow code, we just gave a parameters for that line follow and using the if else statement, if the color detected was red, means the bot which is in the red zone, it used another thresholding value. And once the bot comes out of the red zone, it used another threshold value, which helps us to solve the.
Okay, I like this point. This occurs very often when you are controlling systems. You have to adapt the controller. This is called adaptive control. It works in different modes. And one mode was when the black line was on red, that you switch the values of the parameter. Okay, I get that. I think I'm done, Kavi.
Yeah,
Maybe others.
Bharatosh, I can sense a lot of potential to
Yes.
use this kind of a problem to write, say, Lustre or SCADE controller.
Any language. Illustrator has,
Any language.
but the
But
concepts are important.
the
That you can do
concepts,
adaptation.
the whole point of switching modes and doing different things in different modes is a very common kind of thing that happens in most systems. So it's quite interesting to see how they've
Yes.
been dealing with the situation. So where did
Sure.
you find most of the problems in your solution of this problem? What was the technically most recurring problem that you faced? Can you think?
the thresholding values for line follow.
The thresholding value, right? You'll find that when you migrate to a real robot, the same thresholding is going to give you real nightmares because there is a lot of calibration work that needs to accompany this kind of a problem. Okay, so and any other issues in working as a team? Yeah, Parikshit, you were saying?
No, I didn't say anything.
Yeah. So, are there any issues that you'd like to highlight about working as a team under COVID situation?
We every day we met on Zoom, and we every day we solved one part of the problem. Like first we solved the wall follow. We all came together. We did different parts of the code, and then we went on to line follow. Some days some people were not there, so that was a little irritating. So it delayed us a bit. And if all the participants were there for all the meetings, the task would have been finished a bit sooner. So
Okay.
that's it.
And how did this affect your schoolwork? Because you must have had exams along the way and all that. So have we essentially distracted you from school, or has it added to your academic experience?
Sir, it has been added to the academic experience. We are learning new things about coding and all.
Yes,
But
sir.
you've not done badly in your exam because of distractions.
No, sir. A teacher had granted us permission to work on eYantra, as well as after completing the particular work, sir, we were supposed to complete the school task, so that way we never used to miss anything.
Is your teacher here? There was Mazubin, right?
Yes, sir.
Yes.
Is she here?
Yes.
Yeah,
Yes,
Mazubin?
yes, sir. Yes, I'm here.
Hi. Just wanted to ask you how this experience has been for them. Has it been kind of how have you balanced schoolwork with this kind of work?
So yeah, for our school, since we didn't want our students to have overtime on screen, we have excused them from attending classes, the regular classes, and we have recordings of our classes so that the students can access it even after the live class is over. So if there was any work to be done, which is imperative for them to complete, they have watched those videos and they have managed it very well.
Okay. So you won't say that this has been a distraction for them?
Not at all. We don't have exams till standard 8. So they don't have any exams. It is
Okay.
just,
That's
yeah, they just have assessments, subject-wise assessments, and just class, some classwork submissions. But I think they've managed very well.
okay. That's very interesting to hear. In fact, more on this tomorrow when we have the discussion huddle before the valedictory. So nice work, guys. If there are no more questions from our panel here, maybe we can move on to the next team. Thank you, guys. Thank you, Majabin.
Thank you,
Thank
sir.
you,
Thank
sir.
you. They've had a wonderful
sir.
experience.
Thank you, sir.
Thank you.
Okay, so the next team is again from Bangalore and
Yeah,
again from
Rishi, you'll have to
BGS.
speed up.
Yeah, the next team is from Bangalore, BGS National Public School again, and the team consists of Navya, Ruhi, Amogha, and Chanavi. The team's called Young Coders, and here's their video.
Hello, we are from Team 34 Young Coders. My name is Navya from 8th grade BJS NPS. Hello everyone, I am Amogha Jayar from 8th grade.
Hi, my name is Ruhi. I study in the 8th grade from BGS NPS.
Hi, I'm Janvi and I'm from BJS NPS 8th grade. Hello, my name is Navya and I'm from Team 34. This is our simulation video. For this simulation, first we have imported all the classes from the libraries, then we have instantiated them, we have created some global variables, we have initialized the camera and the motors, we have got the height and width of the camera, and we have made some variables for cropping the frame of the picture that the camera captures. We have enabled some distance sensors, and we have defined some functions like go straight, turn, differential drive, wall follow, find centroid, and apply PID, which will help us in our simulation. And then we have called the first while loop, in which which the bot completes the first half of the arena, which is the wall following. If the robot finds any red arena, it will break from the loop and go to the next loop, which contains the algorithm for the next part, which is the line following. Let's run the simulation. Here, first the robot finds its position from the wall. If it's more towards the left, the bot finds the error and move towards the right, and vice versa. It maintains a safe distance from the wall. We had a problem while the robot was passing this under bridge. We dealt with it by decreasing the threshold values. Here the robot completed the first half. Now when the robot identified the red arena, it broke from the loop and went to the next loop, which is the line following. Here first it will find the center of the image captured, and then it will find its center and its position. Depending upon the error, it will perform the actions to go either left or right. This was a simulation video. Thank you.
So yes, that was it. You know,
You can put a list of bloopers at the end or the adventure of solving the problems and so on.
No, sir, actually, we did not have time to do that because we had exams on the way also.
Okay. So one thing I noticed about your bot is that it was not line following, it was following the side of the line. That means that it would keep the line to the left-hand side while it's traveling. Can you explain why you chose to do it that way and not let it be on the line itself?
Sir, when we were making it go on the line, actually it was taking the left side, the remote lines to be the actual line and starts following that and leaves the waypoints in the main line. So we thought it would be better for it to be near the right side so that it properly follows the proper line.
So what was the problem that you were having in that case?
It would just go off the arena and follow the small remote lines other than the main line it would follow.
No, what do you mean by remote lines? I don't get that.
Sir, actually in the path we have a small lines as we can see, like the boundaries for the white arena, I guess.
Mm-hmm.
That it was following those lines.
So you are saying outline lines rather than the main line.
Yes, sir, that outline lines.
Right. So what is the line that you're actually tracking or following in this case?
The middle
The
line.
outline line or the main line?
The main line. In this case, the main line.
So how did you track the line? What is the algorithm that you used? What's the technique that you used?
This centroid only, sir, but we extended the width of the camera a bit so it could cover the main line and follow that one.
Okay, by extended the width, what do you mean?
The
You
width
expanded the size of the image, is it?
Yes, sir.
I see. So why did you choose to do it this way?
As we told, sir, it was going to the boundary line, so we thought this would be better instead of following that.
So did you try any other ways, or is this the first way that came and kind of worked and you just stuck to it?
So we tried slowing down the robot and stuff, but it didn't help much as it finally, when we were doing the left turns, it would go and go to the boundary line. So we thought this would be the better option.
Yeah, so this must have been a problem with managing the HSV settings, do you think? So why do you think that was happening?
I think the threshold, sir, we tried with that also, but I don't think so we had much of a difference with that. All we could have done more, we could have learned with it, but we found this solution to be better, so we went with that.
Okay, Paritosh, you were saying something.
No, couple of questions. One was you used the term, when you described your code, there was something called PID. What is this PID?
So actually, PID is a controller which works with differential drive robots. It as in bang bang controller we use if else statements. As in P controller we just use the unicycle model and work with it, and it
What is
contains.
what is unicycle model and what is this P controller?
So P controller is like a we can say it uses the constants and velocities and works with them as a direct path instead of if else. And sorry, what was the other question, sir?
No, my question was, so in this P controller, what is called proportional controller. See, you would get some reading of amount of error, how close you are to the wall, or how off you are from the center of line. Now, how do you decide the strategy? Where would you move the robot?
Sir, according to the error, if it's more, we would deal it with like a more of KP, and if it's less, it would be with the same KP, but it would have small changes to do, so it would help us.
No, no. So what happened in your code? I mean, how did you first of all decide this constant KP, and this copy was KP was kept constant throughout the movement, or what?
No, sir, it was kept throughout the movement. We decided it by trial and error. We
Okay,
went through
okay,
many years.
yeah, okay. So that was one. But you used the term PID. And where did you get that term PID?
Actually, we had learned it from Arjun sir and Deepa ma'am.
Acha, so Arjun is responsible for this. Okay. Yeah. Okay. Other question was, when you came to the red part, the transition from wall following to the line following, I saw your robot was going very much going off. Its direction was, you know. So what was the difficulty there? Why did it not follow the line there?
Sir, actually, for our code, we couldn't get the threshold value, so we coded the robot to go forward till the red arena is finished and then
Acha.
slightly turn right to find the line again. So
Right.
it was a bit off line.
And what did you do under the bridge? Because you can't see the line there.
Um,
Oh yeah.
yes,
Maybe I'm missing something. Oh, you that happens only in the outside view. You will be
yes.
able to see the line, so that's okay. Yeah, did you have prior familiarity with programming in OpenCV and sorry, with Python and all?
No, sir. Actually, none of us had any experience with it.
So was that sort of good, bad, difficult, enjoyable? What would you sort of
We
put
were
your experience in?
excited when a new topic would be brought on to us. We would
Yeah.
like to learn more and explore more in that.
And how did you share the work?
Sir, all of us actually met for like 1 hour each day and we would work on parts of code. So everyone would give suggestions on a particular code.
We don't know
Yeah,
about pets.
we mentioned the
By this program only we started learning.
Sorry, sir.
Yeah, if I'd like to ask Ruhi,
yeah.
you guys mentioned that you had a problem while traveling under the bridge. What was that problem and how did you solve it?
So basically, when it was going through the underpass, it recognized the overpass or the top part of it as another object or another thing in the pathway. So what we did was we increased the threshold value so that it wouldn't recognize the overpass as a obstacle.
Okay, was that difficult to arrive at that threshold? It would be something on the road and then you have something above the road also, right? So how did you overcome that?
Sir, actually, sir, and he suggested us to reduce the threshold value and we did it through trial and error.
Okay, that worked.
Yes, sir.
So solving this problem which you all did together, what was the most difficult thing? Was it technical? Was it collaborating as a team? Was it distributing work?
For me to participate in many extracurricular activities like this.
So I
Okay,
think it
fine.
was because of that.
Plus,
So
it
become a fan.
exposes us to various other things. So, I mean, it's useful. It's like a win-win situation. There's no losing in any part of it.
All right. All right. So Paritosh, anything to say to that?
No. I mean, I think it's amazing how much your children are doing at at these early levels of schooling. It also points you to these difficulties that come in real problem solving. So hopefully there are solutions to it, and there are good engineering solutions to it. So as you study, go further in your studies, you will find some of the material that you study having bearing on what you did, and it will also motivate you to learn those things because they will come in useful when you solve further problems. So I think this experiential learning that you have had should, I hope, motivate you to you know more principled knowledge that you will be given in your classes.
Yeah,
How
Paritosh.
was the geometry part of it? You had to deal with moving the robot in open loop control along specific directions and things like that. Did you find solving those equations easy, interesting?
It was more like a challenge which we had to uh, challenge ourselves so whether we could do it, and then it was actually fun to take up the challenge and do it.
Okay. And did you manage to complete that well?
Yes, sir.
Yes, and if we finish
Excellent.
it early and then we like tomorrow holiday and like that. Yes, and if we
Excellent.
finish it early and then we like tomorrow holiday and like that.
Okay, excellent. Okay, Kavi, that's it.
Okay. Yeah, fine. We should move on to the last team before we close the session. And you almost done a summing up now itself, but we'd like to
Kavi,
do it after
just
the last team has been.
Kavi,
So Rishi, over to you.
Kavi, just one observation from me.
Yeah.
The all the girls except I think what's her name? Except the new team is already in, right? So all the girls in the previous team look very studious kinds. They have glasses on. 3 of them out of 4
Good Lord.
have glasses, and the one who didn't have glasses probably did relatively more kind of chatting. So I was trying to establish a correlation between being studious and being, wearing glasses and so on. So, for example,
It has nothing to do with it. The one without glasses, Navya, was actually the leader, and she was the one who helped us with the most work.
so I hope,
Rome-
Yeah.
Romesh, both of us have glasses.
yeah. So, so, so does it mean that leaders shouldn't be wearing glasses? So I think that's the correlation.
Actually, I think glasses doesn't have anything to do with it. Studious or not, it just happens when you have a problem with your
Yeah,
eye. Yeah. Doesn't
I think there's like this
it doesn't have
stereotype.
to be. Yeah.
Yeah, it's like a stereotype. The people who wear glasses are studious. That's not exactly true. I mean, the people who work
Yeah, I'm not
hard
a
and
student
study
today.
well are
Or
the people who are
spend more time in front of the computer screens or whatever. Anyway, it was said in a lighter note. Ruhi, don't take me so seriously. So it was said in a lighter
Take
note.
it, take it.
Lastly, what is the average class you guys are in? Janvi didn't speak. Janvi, what classes are you in?
They're all in the 8th standard.
They're all in 8th standard.
All in 8th. Great. I think kudos to all 4 of you. I think for
Amazing.
8th, this is highly commendable. I think in 8th, as I was saying earlier, I couldn't even solve a maths problem, a very simple maths problem of our days of 8th. You can imagine, because I'm more like a dinosaur today in terms of extinct. I mean, I'm past date of extinction actually, but I couldn't solve a maths problem.
Don't give it away, Ramesh.
Sorry,
Don't worry, sir. Dinosaurs are cool.
but they are extinct. But anyway, so
They have a
great.
place on the mantelpiece.
Yeah. Good. All the best to you
Yeah,
in your future endeavors. And the first all-girl team, right?
Yes.
The first girl teams.
It's exciting when I
Kudos.
see a flight which has an all-girl crew or I'm super excited. I think girls are doing a great job. Keep it up.
Thank you,
Great.
sir.
Thank you.
Thank you. Rishi, over to you. We have the last team.
Great presentation and great interaction. The next team upcoming is also a all-girls team. They are from NM Nutan Sarva Vidyalaya in Mehsana in Gujarat, and the team name is Nutan, and as per their school name, and the team consists of Asthabhen, Prapti, and Vishwa. So I'll just play their video, and this is it.
My name is Asta Patel. My school name is Sarva Vidyalaya. I am studying in 9. Our team ID is 168. Our team name is Nutan.
My name is Vishwa Chaudhary. I am studying in.
My name is Prapti Patel. I am studying in 9th class.
My name is Asta Patel and our team ID is 168. Welcome to Final Task Output video. This code is related to initialization, robot, camera and sensors. Over here we apply the masking and try to detect red color is present or not. Over here we measure the distance of sensor from wall and update the velocity of left and right motor as proportional model. In while loop we follow the wall until we not reach the red tunnel. After red tunnel, now start to follow black line. Over here we just take turn at 90 degree in left or right. Over here we just move robot for some T steps. Over here we try to detect 90 degree turn in the path or not. Over here we try to find center point of black line. Over here we change the speed, left and right motor if required according to center point. In while loop we just follow the black line until we reach at the end of path. Now robot nearest to left wall, so it try to move on right side. Now robot nearest to left wall, so it's try to move on right side. Now robot nearest to left wall, so it's try to move on right side. Now robot nearest to right wall, so it's try to move on left side. Now robot nearest to left wall, so it's try to move on right side. Now robot nearest to right wall, so it's try to move on left side. Now it's detect red color means end of the wall following and start the line following. The black line move in the left side in camera image, so robot try to move in left side. The black line move in the right side in camera image, so robot try to move in right side. The black line move in the left side in camera image, so robot try to move in left side. At this point, robot takes a left turn at 90 degree. At this point, robot takes a right turn at 90 degree. The black line move in the right side in camera image, so robot try to move in right side.
Yes, so that was Team Nutan 168, and they're here and this one.
Okay, very nice. In fact, your robot seems to have effortlessly done everything. So
आप हिंदी में बात करेंगे हमें?
हम हिंदी में बात कर सकते हैं, ठीक है? तो ऐसा लग रहा है कि आपके रोबोट के लिए बहुत आसान था ये प्रॉब्लम सॉल्व करने में। क्या बीच में कुछ डिफिकल्टीज थे और कठिनाई ये थे, अगर थे तो वो क्या थे, आप हमें बता सकते हैं?
नहीं सर, ऐसा कुछ नहीं था, क्योंकि हमने एमडी बुक में से ज्यादातर कॉपी किया था, और कौन सा टास्क 3 और 5, टास्क 3 में से सब कॉपी किया था, तो हमारे लिए इतना मुश्किल नहीं था। एमडी बुक में से ज्यादातर कॉपी था।
अच्छा, एमडी बुक जो था वो सब इंग्लिश में था, आपने कैसे कोप किया फिर?
सर हमें हमारे जो सर हैं उन्होंने हमें कन्वर्ट करके दिया था गुजराती में वैसे।
अच्छा, उन्होंने एमडी बुक गुजराती में ट्रांसलेट करके आपको दिया?
हाँ,
हाँ,
नहीं
और उसके
गुजराती
आधार
नहीं,
पे?
सिर्फ हमें समझाते थे कि ये इसके लिए है वैसा।
अच्छा अच्छा, और उसके आधार पे आप इसका सोल्यूशन निकालते थे?
हाँ।
तो सबसे मुश्किल इसमें क्या टास्क था, क्या प्रॉब्लम था?
कैसे आप समझी नहीं सर मैं?
मतलब लाइन फॉलोइंग मुश्किल था, या अपना मोड चेंज करना मुश्किल था, जैसे फ्रॉम वॉल फॉलोइंग टू रेड लाइन डिटेक्शन टू ब्लैक लाइन डिटेक्शन, तो उन सब प्रॉब्लम्स
90
में
एंगल, जो एंगल था ना 90 डिग्री।
90 डिग्रीज।
हाँ।
अच्छा, तो उसको कैसे आपने सॉल्व किया था फिर?
हमने सर वो आगे इमेज ब्लैक लाइन दिखनी बंद हो जाती थी, ऐसे आगे इमेज में दिख जाता था कि वो लेफ्ट है कि या राइट है, इसीलिए हमने राइट या लेफ्ट में ले लिया था।
अच्छा अच्छा, क्योंकि आपका जो रोबोट है वो बिल्कुल ब्लैक लाइन के ऊपर जा रहा था, और दूसरे जो रोबोट्स हमने देखे हैं वो शायद एक लाइन के राइट हैंड साइड पे था या लेफ्ट हैंड साइड पे था, और राइट एंगल पे आपका रोबोट सही जगह पे राइट टर्न मार रहा था, मींस ऑन द ब्लैक लाइन। वो कैसे अचीव किया आपने?
सर हमने जो ब्लैक डॉट्स होते हैं वो जैसे कि 11 to 12, तो हमने मिडल में 15 है तो ऐसे किया, फिर वो राइट टर्न ले रहे हैं लाइन, तो जैसे कि 11 to 20 जगह डॉट 25 से 35 तक हो गए, तो उसमें हमने मिडल लिया 30, वैसे करके हमने लिया।
अच्छा अच्छा, तो आपने कैसे इंश्योर किया कि आप ब्लैक लाइन से आगे नहीं निकल गए? ऐसे कभी हुआ था क्या?
नहीं, ऐसा कुछ हुआ नहीं सर, हमारे ऐसी
अच्छा,
प्रॉब्लम।
अगर आपका स्पीड हाई था, ऐसा नहीं हुआ कि रोबोट आगे ही निकल जाता है और लाइन को नहीं ट्रैक करता है?
नहीं सर, क्योंकि हमने जो टाइम लिमिट थी वही ली थी, और हमें ऐसा कुछ हुआ नहीं प्रॉब्लम।
ऐसा हुआ नहीं। अच्छा, परितोष,
श्योर, नहीं नहीं
हम आपको चांस देते हैं, और परितोष जी आपके साथ गुजराती में भी बात कर सकते हैं।
अगर जरूरत पड़ी तो गुजराती में करेंगे, बट बाकी सब ऑडियंस के लिए हिंदी ही सही।
हाँ।
ठीक है, तो अच्छा, बहुत अच्छा प्रयास है, और आपका जैसे प्रोफेसर कवि ने बोला कि आपका रोबोट बिल्कुल लाइन अच्छी तरह से फॉलो कर रहा था और राइट टर्न बहुत अच्छी तरह से टर्न किया। तो अल्गो देखिए, आगे राइट टर्न आ रहा है हमें और आपको तो दिखता है, पर वो रोबोट को कैसे दिखेगा? आपको तो खाली वो इमेज मिलेगी ना। तो आपने एल्गोरिदम क्या यूज किया राइट टर्न डिटेक्ट करने के लिए?
सर हमने कैमरा लिया, जिससे कैमरे में वो कैमरा क्लिक करके हमें देता है कि नहीं ये आगे ऐसे वगैरह।
नहीं नहीं, कैमरा तो पूरा पिक्चर देता है कि पहले थोड़ा लाइन ब्लैक आगे जा रहा है और फिर ब्लैक यहाँ पे है, पर उसके लिए आपने कुछ कुछ स्पेसिफिकली एनालिसिस कैसे किया, कोड कैसे लिखा राइट लाइन डिटेक्ट करने के लिए?
समझने नहीं आया सर, क्या सर?
आपका कोड दिखा सकते हैं? राइट लाइन का कोड दिखा सकते हैं, राइट लाइन डिटेक्शन का?
राइट लाइन सा कहीं लिखते हो स्क्रीन प्रेजेंटेशन।
नहीं नहीं, परितोष, इनका एक और प्रॉब्लम था कि, अच्छा, आप क्या हमें बता सकते हैं कि आपने काम कैसे किया, ये प्रॉब्लम सॉल्व कैसे किया? आपका मशीन, किसके पास मशीन था, और मशीन पे कैसे आप लोगों ने काम किया, ये बता सकते हैं?
स्कूल में
किया सर हमने, हमारे पास
नहीं नहीं, आप, अच्छा, आप लोगों के पास लैपटॉप या मशीन है क्या?
नहीं है।
अच्छा,
तीनों
स्कूल
के
में
पास
किया
नहीं
था।
है। अच्छा, और घर कितनी दूर है स्कूल से?
सर 5 से 10 मिनट लगता है, 5 से 10 मिनट होता है, ज्यादा नहीं।
अच्छा, मतलब आप स्कूल में ही रह के सब काम करते थे क्या, रात को भी?
हाँ हाँ।
तो स्कूल से कभी नहीं निकलते थे?
नहीं सर, हमारे
नहीं सर,
तो
ऐसे
काम
नहीं,
कैसे
हम
किया फिर
हमारे
आपने?
घर से ही आते थे।
अच्छा, तो काम कैसे किया फिर आप लोगों ने?
सर हम जैसे कि दोपहर में टाइम मिलता है 1 से 4 बजे का, तो हम तभी आके काम कर लेते हैं, या फिर टाइम ज्यादातर तभी मिलता है, बाकी सेट नहीं होता, तो हम 1 से 4 के बीच में 1 से 4 आके करते हैं।
अच्छा,
और सर
सो
थोड़ा
परितोष
हेल्प करते
दैट्स
थे, सर थोड़ा हेल्प करते थे, कुछ गाइडेंस वगैरह?
प्रॉब्लम्स वगैरह नहीं सर, बट हमें कुछ इंग्लिश में हो और समझ में नहीं आता, तो वो सर सिर्फ गुजराती में कन्वर्ट करके देते, ज्यादा नहीं।
कोड आपने खुद ही लिखा?
नहीं सर, पूरा कोड खुद नहीं लिखा, कुछ एमडी बुक में से कॉपी किया है।
हाँ हाँ, वो तो रहेगा, वो तो आप लाइब्रेरी से यूज कर ही सकते हैं। अच्छा, दूसरा, आपका रोबोट जब राइट टर्न लेता है तो क्या होता है, वो इमेज में तो आपको आगे का दिखता है, आपको रोबोट के सेंटर को बिल्कुल टर्न पे ले जाके बाद में उसको इन प्लेस राइट टर्न घुमाना है, जगह पे ही राइट टर्न घुमाना है, बरोबर है? डिफरेंशियल ड्राइव से उस टाइम
मतलब
पे वीडियो,
यहाँ रोबोट है और वही उसको राइट टर्न लेना है।
हाँ, आपके रोबोट का सेंटर जब वो टर्न पर पहुंचेगा तब राइट टर्न लेना है, और फिर वो घूमने लगेगा राइट टर्न, तो टर्न खत्म हुआ कि नहीं वो कैसे आप डिटेक्ट करते हैं?
सर राइट टर्न लेने के लिए हमने राइट व्हील की जो स्पीड होती है वो कम की और लेफ्ट की थोड़ी बढ़ा दी, तो उसने राइट टर्न ले लिया।
पर कितना टाइम तक वो करते रहे?
ऐसा कुछ याद नहीं पूरा।
अच्छा, ठीक है।
ये कुछ कैलकुलेशन करके किया या ट्रायल एंड एरर से किया?
हाँ,
ट्रायल एरर से किया।
अच्छा,
अरे
मतलब
तो
आपने थोड़ा सा टाइम
ये
के लिए इसको
90
राइट टर्न किया,
हाँ
और फिर अगर हर बार वो राइट टर्न मार के सही जगह पे आ गया तो वही हिसाब यूज करके आप आगे बढ़ते थे क्या?
हाँ, यस सर।
नहीं, मैं एक
अच्छा,
सवाल पूछता हूँ इधर, कि अगर वो 90 डिग्री की जगह 60 डिग्री टर्न है तो भी आपका कोड चलेगा?
नहीं सर, वैसे तो नहीं चलेगा
अच्छा,
अगर।
ये 90 के लिए ही फिक्स बनाया है?
हाँ
अच्छा अच्छा अच्छा, ठीक है।
और दूसरी बात कि ये आपका रोबोट राइट पे दोनों टर्न है मेरे ख्याल, लेफ्ट ट्रैक पे लेफ्ट टर्न भी है और राइट टर्न भी है 90 डिग्रीज, जहां तक मुझे याद है। तो क्या संभावना है कि आपका रोबोट आगे जाएगा? किस कंडीशन में आपको लगता है, किस स्थिति में रोबोट आगे जा सकता है, और नहीं जाए इसके लिए आपने क्या किया? क्योंकि जैसा प्रोफेसर साहब ने कहा कि आप बाहर से जब देखते हैं आपको लाइन दिखता है, अब रोबोट को कैसे दिखता है और कहाँ पे रुकना है? कैमरा भी है, लेकिन कैमरा के बाद क्या होता है कि रोबोट वहीं पे रुके?
सेंसर से पता चलता है, सेंसर 1 और 6 लिया था जिससे पता चलता है सर। वॉल फॉलोइंग से भी पता चलता है कि हमारा रोबोट कितना दूर है, या फिर हमारा रोबोट अगर इसको सीधा ही जाना है और वो थोड़ा लेफ्ट या राइट होता है तो हम उसको मिडल में लाने का ट्राई करते हैं वैसे।
अच्छा, सो परितोष, एनीथिंग एल्स?
नहीं, ऐसे तो सब ठीक है। हाँ, एक क्वेश्चन पूछ सकते हैं, आपने वो कोड दिखाया था, उसमें आपका जो आप वॉल फॉलोइंग करते हैं, हाँ, आप वॉल के कितने दूर है वो तो आपको सेंसर दे देगा, सेंसर का वैल्यू बताएगा, आप वॉल राइट वॉल के पास हो, लेफ्ट वॉल के पास हो, उसके हिसाब से रोबोट को कितना टर्न करते हैं आप? आपने कुछ प्रोपोर्शनल कंट्रोल यूज किया ना?
क्या
प्रोपोर्शनल?
हाँ, प्रोपोर्शनल कंट्रोल।
પ્રોપોર્શનલ કર્યું છે ને તમે?
हाँ हाँ हाँ।
તે પ્રોપોર્શનાલિટી કોન્સ્ટન્ટ કેવી રીતે નક્કી કર્યો? હાઉ ડીડ યુ, आपने वो फिक्स कैसे किया कांस्टेंट?
सर वैसे तो आर और एल डिवाइड करके सेट करना था ना, वैसे तो नहीं हुआ सर, कुछ थोड़ा होता नहीं होता वैसा था, तो फिर हमने वन डिवाइड
नहीं, आप घबराइए मत, आप आराम से बताइए आपका एक्सपीरियंस क्या है। मुझे आपको परफेक्ट आंसर नहीं देना है, आपने क्या किया था, क्या डिफिकल्टी आई थी ये बताइए और कैसे किया। ओके, कुछ वैल्यू तो डाला है कोड में, वो वैल्यू आया कहां से और कैसे वहां पे पहुंचे, आपका एक्सपीरियंस बताइए।
ખબર નથી સર.
ના ના, તમે કર્યું છે ને, કે વેલ્યુ નાખી છે તો એ આવી ક્યાંથી? તમે કંઈક ટ્રાયલ કર્યું હશે, કાંક સમથિંગ મસ્ટ હેવ ગોન રોંગ, સમથિંગ મસ્ટ હેવ ગોન રાइट। बेधड़क बताओ, व्हाटएवर इज देयर आप दिखाइए। वो के वैल्यू 3 में से किसने डाला वो वैल्यू?
सर मैंने किया था, मगर
हाँ
मुझे समझ नहीं आया कि आप एक्चुअली पूछना क्या चाहते हैं, कुछ
नहीं
समझ
नहीं, वो
नहीं.
के वैल्यू आपने कितना डाला है अभी? माने कि 0.6 डाला है, मैं ऐसे एग्जांपल ले रहा हूँ, तो 0.5 क्यों नहीं डाला, कैसे नक्की किया?
सर वैसे तो हमसे कुछ ज्यादा नहीं हुआ था, लेकिन हमने 1 को 255 से डिवाइड किया था, वैसे आप पूछ रहे हैं।
हाँ
हाँ, तो हमारा पहले तो हमने L57 लिया था, जो दो टायर के बीच का जो अंतर होता है ना, वो 57 था, और जो रेडियस होती है वो 20 थी। तो हमने इसको डिवाइड किया 57 to 20, लेकिन फिर भी कुछ हमारा रिजल्ट ठीक नहीं हुआ, इसलिए हमने ऐसे ट्राई किया कि 200 लेंगे, 100 लेंगे, वैसे तो हमने
अच्छा
हाँ वैसे एक वन डिवीजन 255 लिया है।
अच्छा, ट्रायल एंड एरर से किया।
हाँ
अच्छा अच्छा, सही।
No,
ओके
but I
सर,
think
आई एम डन।
Sir Pandya, I think they came to the
Okay.
ballpark by doing that radius by whatever, you know, but couldn't get there. So then they did. So they didn't jump to hit and trial, is what my understanding is. They
Right,
first
they
did,
tried analysis. Yeah,
they tried analysis and then they went to
yeah,
probably in the
that's noteworthy, definitely।
proximity of that number they did a hit and trial.
अच्छा, एक लास्ट क्वेश्चन पूछ ले। आप ये प्रोजेक्ट करते थे तो कुछ और सब्जेक्ट के बारे में जानने के लिए कुछ विकिपीडिया वगैरह कुछ देखा आपने?
नहीं।
ये ह्यू वगैरह के लिए, या ये क्लोज लूप कंट्रोल वगैरह की बात हो रही थी ना?
सर से हेल्प ली थी।
हाँ,
सर से हेल्प ली, हमारे जो सर है ना उनसे।
जी जी जी, ओके।
मेरी तरफ से लास्ट सवाल, आप कौन से कक्षा में हैं तीनों?
9।
और आप 3 ही मेंबर हैं टीम में या चौथी भी कोई लड़की?
नहीं 3 ही है।
3 है और तीनों कक्षा 9 में हैं।
हाँ।
क्या क्या सब्जेक्ट पसंद है सबसे ज्यादा जो स्कूल में पढ़ाई कर रहे हैं? कौन सा विषय सबसे ज्यादा? हाँ,
मैथ्स, साइंस।
बाप रे,
अरे वाह,
मैथ्स और साइंस, चलो गुड, वेरी गुड, बहुत बहुत बधाई आप लोगों को, आपने बहुत अच्छा करा। तो आप जो एक साथ बैठे हैं इस वक्त मीटिंग के लिए भी, ये कॉल के लिए, तो ऐसा ही आप घर पे अलग अलग कंप्यूटर नहीं है, एक ही जगह पे?
सर घर पे है ही नहीं, इसलिए हम यहाँ आए स्कूल में।
हाँ, तो स्कूल में आपका ये डेस्कटॉप पे कर रहे हैं ना काम आप? लैपटॉप तो नहीं है वहाँ पे?
ये लैपटॉप सर का है जिसमें से हम बात।
अच्छा, सर का लैपटॉप है। जब सर का लैपटॉप नहीं होता था काम करने के टाइम पे, तो क्या साधन था आपके पास?
कंप्यूटर्स है ना यहाँ लैब में, उसी से।
हाँ, डेस्कटॉप है, डेस्कटॉप है ना, डेस्कटॉप है ना?
हाँ।
थोड़ा बहुत फार गुजराती मने पण आवते, मैं राजकोट जाता था मैं, तो
अच्छा अच्छा,
राजकोट को आप गुजरात नहीं मानते हैं, उसको आप सौराष्ट्र बोलते हैं, वो अपने आप को अलग बोलते हैं, आप अपने आप को अलग बोलते हैं। तो थोड़ा बहुत गुजराती समझता पूरा हूँ, बोलता थोड़ा हूँ। तो बहुत बहुत बधाई, बहुत अच्छा काम किया आप लोगों ने।
थैंक यू।
आप
अच्छा, बहुत ही अच्छा काम किया।
मैं आई ऑल्सो वांट टू से
Paritosh, I will request you to
બહુ સરસ કામ કર્યું છે। તમારી પાસે કમ્પ્યુટર નથી છતાં તમે આટલા આગળ વધ્યા છો। તમને અને તમારા શિક્ષકને પણ ખૂબ જ અભિનંદન।
थैंक यू।
या
Abhinandan from us also. Thank you. In fact, Paritosh, would you please come up?
सर एक आखिरी सवाल पूछ सकता हूँ?
हाँ, बोलिए बोलिए बोलिए।
आप तीनों बेटियां, तीनों लड़कियां अपना अपना नाम बताइए और आपके पिताजी क्या करते हैं, एक एक करके बोलिए।
મારું નામ આસ્થા છે, મારા પપ્પા ખેતી કરે.
अच्छा
મારું નામ પ્રાપ્તિ છે અને મારા પપ્પા મિકેનિકલ છે.
अच्छा
क्या मैकेनिकल गाड़ी?
મારું નામ વિશ્વાસ છે અને મારા પપ્પા ડેરી કરે. ડેરી છે
अच्छा
અમારી પોતાની.
खूब सरस.
सलूट सलूट, ये देख रहे हैं मेरा चित्र में सलूट देख रहे हैं?
हाँ.
Yes.
वेल डन
वेरी
वेल डन.
गुड, बहुत अच्छा काम किया आप लोगों ने, बहुत अच्छा काम किया। वो भी आपने किसी और के कंप्यूटर में जाके रोज 1 से 4 बजे तक श्रम करके आपने आप यहाँ तक पहुंचे, वो बहुत बहुत गौरव की बात है। मैं पूछता हूँ अभी प्रोफेसर पंड्या को हमारे तरफ से वो समिंग अप करें, और शायद रोमेश जी भी 2-1 शब्द बोले हमारे behalf पे। तो
For
परितोष
this,
first, then Romesh.
it is on this team, right?
No, on the whole thing, the whole proceedings.
On the whole team. So what
including
language?
them.
Go on in Hindi or English? English.
Nice. First you give a short one for these girls in Gujarati, and then you talk about the entire thing.
नहीं, हिंदी में रखेंगे। नहीं, बहुत देख के बहुत खुशी होती है कि बच्चे इतना सब करते हैं, इतना सब एडवांस। या आपने राइट टर्न वाला जो आइडिया डाला था, हमें बहुत खुशी हुई। और वो भी बिल्कुल सेंटर में जाके आपका रोबोट टर्न होता है राइट टर्न के। तो काफी कुछ ट्रायल्स हुई होगी आपकी, तो मैं इसके लिए आपको बधाई देता हूँ। आशा है कि इससे आपका कंप्यूटर में इंटरेस्ट बढ़ेगा और आप आगे जाके आप कुछ इसमें ऐसा करके दिखाएंगे कि हम सच्ची कुछ गर्व ले सकें। स्टार्ट किया है, बहुत अच्छा दिखाया है, और आपके शिक्षक को भी बधाई। आपने इतना एक्सेस दिया है बच्चियों को काम करने को, तो उसके लिए बहुत अभिनंदन। मैं एक चीज बोल सकता हूँ, जो आप क्लास में पढ़ेंगे वो एक चीज है, और जो एक्सपीरियंस अपने आप प्रॉब्लम को फेस करके पढ़ेंगे उसका कुछ अलग ही मजा है। और रियल लाइफ में असली प्रॉब्लम आने वाले हैं, उसमें क्लास का नॉलेज यूज होगा। तो आपको आशा है कि आपके सॉल्यूशन में थोड़ा क्लास का ज्योमेट्री वगैरह का नॉलेज भी काम आया होगा, और आप अब समझ सकेंगे कि वो सब क्यों आपको सिखाया जा रहा है।
Yes.
In fact, Paritosh, we have their teacher also here, Mehul Patel.
मेहुल जी, आपको अभिनंदन।
थैंक यू सर।
मेहुल भाई क्या छे?
तो बगल में बैठे हैं।
अच्छा मेहुल भाई, हाउ मच, कितना हेल्प करना पड़ा था और कितना इन्होंने पिकअप किया? क्योंकि हमें आगे टीमों में भी ये आपका फीडबैक काम लगेगा।
हाँ, मतलब शुरुआत में जब ये इनका काम हुआ तो उनको कंप्यूटर लैंग्वेज के बारे में पता नहीं था।
हाँ।
तो शुरू में तो पाइथन प्रोग्रामिंग में काफी मतलब वो ट्रबल हुई, राइट। लेकिन बाद में एरर सॉल्विंग हो गया, और ज्यादातर एमडी बुक में जो कोड दिया था, राइट, ऑलमोस्ट उसको असेंबल करके ही इनका कोड बन रहा था।
अच्छा।
तो जब कभी कभी कंपाइलेशन एरर में उनकी जो नॉर्मल मिस्टेक्स होती थी, राइट, वहां, और ज्यादातर तो जो वीडियोस ऑलमोस्ट लेक्चर्स होते थे ऑनलाइन जो वेबएक्स के अंदर, वो भी इंग्लिश में होते थे। तो वो मतलब हम गुजराती में उनको एक्सप्लेन करते थे कि वो कैसे काम करता है, लॉजिक क्या है, फंडामेंटल्स। मैथ्स तो उनको समझ में आ जाता था, राइट, ज्यादा उसमें डिफिकल्टी हो रहा था। लेकिन जो फंडामेंटल्स जो थे वो मतलब पूरा हम गुजराती में कन्वर्ट करके उनको एक्सप्लेन करना, वैसा काम हो रहा था यहाँ पे।
आप कंप्यूटर पढ़ाते हैं क्या?
हाँ, मैं कंप्यूटर पढ़ाता हूँ।
अच्छा, थैंक यू। रोमेश जी।
तो आई थिंक पहली बात तो इस लास्ट टीम के लिए, टीम आईडी 168 नूतन, आपका काम वाकई नूतन है, आपका काम नूतन है, और आप लोगों ने बहुत बढ़िया काम किया है। और फिर एक बार मेरा विश्वास, मैं जैसा मैंने कहा, राजकोट 10 साल मेरा राजकोट से रिश्ता रहा। आई थिंक राजकोट की मिट्टी में कहीं एक भावना है सीखने की और कुछ कर गुजरने की, जो मैंने शायद देश के हर एक प्रांत में नहीं देखा है। प्रांत राजकोट गुजरात जैसे प्रांत भी हैं, लेकिन जो गुजरात की मिट्टी में एक एंटरप्राइज और एक सीखने की भावना है, साधन की कमी होने के बावजूद सीखने की भावना, ये मैंने गुजरात से सीखा है। कम से कम साधन में ज्यादा से ज्यादा कैसे आदमी सीखे और करे, ये अगर मुझे कुछ अनुभव हुआ है जिंदगी में 10 साल राजकोट में या गुजरात कह सकते हैं। एक टाइम पे मेरी मम्मी का एक फ्लैट भी था अहमदाबाद में, तो जब हम कश्मीर से निकाले गए थे तो उन्होंने घर लिया था कि कहीं एक ठिकाना रहना चाहिए। बट एनीवे, सो गुजरात में एक ऐसी खास बात है, और जब ये लड़कियां कर रही हों तो इसमें और भी मुझे सुंदर लगता है। और आप जिस टाइप के बैकग्राउंड से आई हैं उसको देखते हुए ये अपने आप में बहुत बड़ी, जिसके साथ साधन हो, वातावरण हो, इंफ्रास्ट्रक्चर हो, उसके लिए भी करना कभी कठिन हो जाता है क्योंकि इच्छा नहीं होती है। लेकिन आप लोगों की इच्छा की प्रबलता देखते हो से ये लगता है कि आपकी इच्छा बहुत प्रबल है करने की। जैसे आप तीनों बहनें बैठी हुई हैं एक साथ, एक दूसरे की आपने मदद की है, बहुत बहुत बधाई, बहुत बहुत आपको बहुत बहुत शुभकामनाएं आगे वाले समय के लिए। तो अब मैं थोड़ा अंग्रेजी में आता हूँ पूरे प्रोसेस के लिए, जो ओवरऑल क्विकली आई थिंक वेरियस शेड्स, आई थिंक मिक्स्ड, आई थिंक जो छोटे बच्चे हैं 8 कक्षा के, 9 कक्षा के, उन्होंने बहुत वाकई में बहुत ही बढ़िया काम किया है। कुछ लोगों ने एक्सप्रेस भी बहुत अच्छे से किया है, जैसे आईआईटी दिल्ली की केवी की टीम थी, या एक आधी और टीम थी जिन्होंने ये जो टेक मिनियंस की टीम थी, आई थिंक बहुत, सूरत से, वो भी गुजरात से, फिर एक बहुत अच्छा काम किया उन्होंने भी। तो ओवरऑल जो है, जो यंगर टीम जो 8-9 कक्षा से, जो मैं उम्मीद नहीं करता था, क्योंकि अब मैं जो उम्मीद नहीं थी उससे बहुत बढ़कर काम किया है। तो इससे मुझे लगता है कि ई-यंत्रा का सहयोग, ई-यंत्रा का लोगों को सिखाना, ये एमडी बुक की जो बात हो रही थी, या अवेलेबल ऑन कॉल, मुझे याद है कवि भाई, आपको भी याद है कि पिछले साल जो अप्रैल में ई-यंत्रा का मेन इवेंट का फाइनल होना था, वो पोस्टपोन होते होते फिर फेस टू फेस से वो एक ई फॉर्मेट पे आया, तो फिर हमने उस पर भाग लिया। तो ये अब एक जिंदगी की सच्चाई हो गई है। तो मुझे लगता है कहीं ना कहीं सीखने की दिशा में, मुझे लगता है कि यंत्रा के माध्यम से या टेक्नोलॉजी माध्यमों से इन जनरल, आई थिंक मैं देखता हूँ कि शायद प्रोफेसर पांड्या हो, प्रोफेसर दासगुप्ता हो, तो कहीं ना कहीं ये टेक्नोलॉजी, बैंडविड्थ और ये इस चीज को और व्यापक बनाएगा, क्योंकि सिर्फ सीखना या करना नहीं है, उसको कार्यान्वित कैसे किया जाए, उसको प्रैक्टिस में कैसे लाया जाए, आई थिंक those means will also be progressed. But coming back, I think even class 11, some presentations are great. I think the first one of Standbots was quite good. Sorry, Team 66, which was a mix of young and old, which was 11 and 9, was quite good. Standbots I had kind of come in the middle. I didn't see it, and 2 I missed completely. But overall, I would say it's a great initiative, Kavi. The fact that, that old adage, that old what you call thing of catch them young. I think you caught them young now. I think without waiting for you to get to the eYantra labs and go to engineering colleges, you are catching them young. I think your eYantra is in the process of creating a recipe of how to catch them young and how to harness it. Hats off to you and your colleagues. I think you built a tremendous kind of infrastructure and organization to make such things happen. It gives me hope. It gives me a lot of confidence, and I would love to be, kind of be associated with this in whatever way. And I think that I keep hearing this, that the next century will belong to India, technology, etc. India will get its pride of place. I think the only negative, not so negative, area of improvement, I think as we make this journey, and I'll say this in summary just quickly, I think the only thing that we need to reinforce is how do we train our children to do first time right? How do we create equivalent of MD books and algorithms and check sheets and so on, so that we capture those what ifs and what not to do, some do's and don'ts, so that we inculcate this culture of first time right. And there is merit in learning from mistakes also, but if you can create that culture of first time right, mistakes will be minimized and time will be saved and resources will be. Thank you very much. All the best to the eYantra team. All the best to all the participants. I'm super excited. In fact, if you see, my house is in a mess. My wife is terribly angry that I started this work in the house, but I took time out to do this because to me it energizes my batteries personally, and I love this. Thank you very much.
Thank you, Romesh. In fact, we'll give you another opportunity
sir.
because we're having the next sessions beginning at 2 o'clock. You're most welcome to be there with us. But we didn't want to stress our panelists too much. That's why we've given you slots. But thank you very much for being with us, and thank you for blessing our kids by very encouraging words. Paritosh, anything you'd like to say before we close?
Yeah, just want to congratulate all the participants for the amazing work they have done. Having come this far itself is a major achievement, and you are all winners. Second thing I would like to tell you is that this experiential learning, that opportunity that you go through eYantra, is something unique. I hope it will charge your batteries towards learning and engineering and doing things yourself and making things yourself, making it for us, making it for the country. So I think this is a tremendous start to a big journey. That is how I would like to look at it. And you have all started very well. Other thing I would like to say is that while you have participated in this project and faced many difficulties, put together many ideas and come up with solution, I hope you will have learned the importance of also knowledge and how to study some solutions which are uh, which are there in books. So a curiosity as to how you can make your solutions better, more general, how you can make them apply to other situations, and how knowledge can help there is a very valuable resource. So I would urge you not only to solve the problem, but to little bit think beyond the problem and see what is the literature around that problem. What are the other situations in which this can be applied? These are the kind of things that I would urge you to do. Generalize from this. And again, once again, congratulations to all the participants. Thank you.
Thank you, Paritosh. In fact, I can say that I'm delighted at the response of both the participants and our panelists. I think we are on an amazing experience together. This is the start of a journey, a very exciting journey, and I can speak for the rest of our team that we've enjoyed this every bit as much as you have.
I think participants should mute their mic.
I'm sorry for that.
Yeah, we have. Yeah. So I'm saying that this has been an amazing journey for all of us, and I must give credit to our team, the core team members who've kind of picked up this janda and have been running with it, which is Deepa, Arjun, and Aditya. Hopefully, we'll hear more from them this evening after the last session. But I think all of you have done a great job. We are in it together. We are in on a very interesting journey together, and I hope that we get to engage with more of you as we go along. So thank you very much, guys. God bless. Jai Hind. And we'll reassemble now after lunch. We have very little time for lunch, but we'll be back at 2 o'clock.
Kavi,
thank you very
I may not
much.
be able to afternoon today, but join for the valedictory tomorrow.
Valedictory. ठीक है, no problem. Thank you very much.
Thanks,
Paritosh. Really appreciate this.
Yeah. Bye.
Thank you, Paritosh sir.
Bye, Ramesh. It was pleasure listening to you.
Thank you so much.